Hello, and welcome to CSCI 21, Programming and Algorithms 2. My name is Matt Cervantes, and I'm going to be your instructor for the course. In this video, I'm going to be spending a fair bit of my time walking through the syllabus and basically showcasing how I've organized the course and sort of what the expectations for you as a student are while taking the class. Obviously, I'll be introducing myself a little bit more, giving you a little background about me, and then I'm going to hopefully capstone the whole thing with our first programming lesson, where I'll be introducing more than anything the language we'll be using to demonstrate the concepts and doing a little bit of review of concepts you probably should already know before entering the class. Before we jump into all of that, though, there are just a few sort of high-level things that I want to kind of quickly talk about for this course, just so that people understand kind of what the expectations are, just sort of a week-to-week thing. So the first thing I want to mention is obviously you're watching this lecture right now. This means you're on my YouTube channel, and you found your way to the first lecture that way. I want to emphasize that YouTube is the primary medium that I use to deliver all of the lectures for the course. So that is just sort of where I put everything. And then on top of that, I also really want to emphasize the fact, if you've never taken a class with me before, a programming class anyway, that my lectures are the primary way that I deliver all of the course content. So if you've taken an online class before, even though this is a hybrid class, but if you've taken any kind of an online class before and that had lectures, you might have had classes where the lectures weren't maybe necessarily necessary, like you didn't feel like you had to watch them or you could kind of skim them, and that maybe the teacher provided a lot of like PowerPoints or PDFs or other kinds of course material that like basically you would just read that and then that would more or less be what you would need. So I'm trying to set the expectation right up front that that is not at all how I structure my classes, my programming classes. For these courses and for this course in particular, all of the content for the course is coming through the lecture. So I'm saying that because my lectures really aren't optional. And my expectation is that all of my students will have watched all of my lectures. Not only do I deliver just the content for the course, like introducing the new concepts and demonstrating like how they work, but also I'm not just demonstrating those concepts like on a abstract way, but I'm also showing you how I want you to implement those concepts when you do work in the class. So when I have assignments that I give you, I'm really demonstrating to you like the intentional way that I want you to demonstrate to me when I evaluate your work that you understand the material, right? So I'm just trying to make that really clear that like maybe in other classes you could just sort of not watch the lectures. That's really not the case here. So you really have to watch those lectures to be able to get all the material and also kind of how I want you to demonstrate that understanding to me. So if that's not really something you're interested in, and then that this might not be a great class for you. And I just want to be upfront about that, before we get too far much further into the syllabus. Okay. The other thing I'm just referring to my notes here that I wanted to mention is that again, it's online. The lectures portions is online. It's all on YouTube. Real strong piece of advice. I really strongly encourage you all to watch my lectures at 1.5 or double speed. It is the best way, in my opinion, to get through these lectures. I speak at a cadence that I think actually you can still understand everything pretty well, even at double speed. And that means you can just get through the lecture twice as fast. And that might prove to be particularly helpful to you because I also want to let you know right up front that though the first week is a little weird, once we get going into the semester, I basically will put up one lecture every week, and that lecture will cover a week's worth of material, but they tend to be long lectures. They average around 2 hours. So the reason I do that is really that I'm kind of mirroring what used to be the traditional in-person experience of this course, where you would basically meet maybe twice a week and you'd have an hour lecture twice a week for the course. I basically just took those 2 hours that you would meet and I mushed them into one big lecture, and then I pushed that up for you every week, and that's what you are expected to watch. So again, watching it at 1.5 and double speed can get you through that lecture a lot faster. And then of course you have the advantage of being able to rewatch the lecture as many times as you like because it is recorded. So, that's the big advantage for you. So anyways, that's just sort of like some quick high level things I want to make sure I say before I get too much further into anything else. I guess next thing I'll roll into here is a little bit of a introduction. I already said my name, Matt Cervantes. I'm pretty informal about how people address me in the course. So like, if you want to call me Professor or Mr. Cervantes, that's fine. But 9 times out of 10, you're going to just hear me talk to myself and say Matt. Most people just call me Matt. It's what I go by. So whatever's comfortable for you. I'm pretty darn informal. So, I want you to feel comfortable just sort of talking to me. And hopefully that'll make it easier for you to come to me if you have questions, which I'm sure you probably will. Um, Let me see, anything else about myself? I have a bachelor's degree in computer science from Chico State. I have a master's degree in entertainment technology from Carnegie Mellon University. And I've been a professional software developer for about 20 years or so. I kind of stepped away from that now in the last like year or so. I'm not doing as much consulting work as I used to, but that is kind of like the vast majority of my career was spent doing that. Teaching has been my full-time job for the last, I don't know, 5 or 6, 7 years now. And I really love doing it. But I want to emphasize the professional experience I have because a lot of times the things that I talk about in the class and the concepts that I cover and the manner in which I talk about code and when I implement code in front of you, I just want you to know it is coming from a place of experience, coming from my own professional experience, and it's not just something I necessarily read out of a book. Okay, well, but with that said, I think we're going to go ahead and jump on into the syllabus. I already mentioned that most of my lectures are about 2 hours in length. I'm going to try my best to keep this under that, but no promises. But I know that it'll be hopefully able to get through a little bit faster because one of the first things you're going to see on the syllabus is, well, of course, our beautiful image here. And if you ever want to find us in Canvas, this is where it's at. But one of the first things you'll see on the course catalog information is that there is a prerequisite for the course, CSCI 20 or the equivalent. So I can kind of rest assured that all the folks in this class have probably taken at least one other college course before. So I'm not talking to a bunch of people who have literally like this is your first time in college. So I'm going to try to go through a little faster making those assumptions. So here's the course description. I'm not going to read it. It's the description straight from the catalog. Transfers to the CSU UC system. These are the student learning outcomes for this course. I cover all these things, and actually I tend to cover more. Course section information. So I've already kind of alluded to it a few times, but this is a hybrid course. So that is possible that maybe you've never had a hybrid class before. So I will briefly talk about that. So what that basically just means is that the course has always been a lecture lab course. Hybrid meaning in this case that the lecture portion of the course is online. Okay, so that's why I was saying all of my lectures are going to be recorded and delivered through YouTube. So that's the online portion of it. So I'm just going to have those recordings ready for you and you'll be able to watch them every week to get the course content. There's no in-person component for the lecture. However, for our lab, there is an in-person component. So our lab is scheduled to meet in MC 146 on Monday and Wednesday from 9:30 to 10:45. That is going to be an expectation that you go to every single one of our labs, unless I've explicitly said you don't need to go to one. My expectation is that you will be in lab. And I'll talk about it a little bit more here, but the big reason for that for me will be that will be a point where I will be giving out our quizzes, and we'll likely have quizzes at least one every week where I kind of do some review. And then also we'll spend that lab time obviously doing the work that I've assigned for the week. It's an opportunity for you to sit and actually get help. And my hope is that I might actually have a few more activities for us to do during lab to be able to help make the curriculum a little bit more fun for you and help you feel more engaged and also build a little bit of a community with the people in the class with you. So that's sort of how the class is going to be modeled. Again, there's my name. Contact information. I have both my Canvas inbox and I have my traditional email account listed here, but I'm going to be honest with you. If you want to reach out to me, not during class or not during office hours, Canvas inbox is by far the best way to go. Canvas inbox is kind of the place that really only students reach out to me through that way, and so I check that far more regularly than I check my traditional email, because in my traditional email I get a lot of messages from lots of people, not just my students, and so I want to respond to students faster, so that's the best way to get a hold of me. All right, let's move on down to office hours. I'm going to go ahead and just click on this link for the page. I'll just open another tab. Okay, and you can see here that my scheduled office hours are actually all in person, and they're all on Monday, Tuesday, and Wednesday. So on Mondays, and actually we'll be seeing each other on Mondays and Wednesdays for lab, but I have another class after our lab, and then after that class ends, I'm going to offer up another hour of office hours. So between 1:30 and 2:30 on Mondays and Wednesdays. And then on Tuesdays, I have a little bit more of an opening. So I'm going to fill that with the 12 to 2:30 time. So it's a 2.5 hour block that you can come by my office and get help with anything you need help with, or just ask questions, or if you just want to hang out and chat. Actually, I've had students in the past where that was sort of like kind of the student hangout, I guess, over in the MC building. I also am a big fan of playing chess. I always have a chessboard ready to go in my office. So if you walk in there asking you a question, I may ask you, hey, do you want to play a game? So just be warned. Um, I realize that not everybody's going to be able to come to my scheduled office hours. It doesn't really matter what days or times I pick for office hours. It's not going to be perfect for everyone. So that's why I have the additional office hours listed here. And that's really just an opportunity for you to reach out to me and then let me know, hey, I want to chat, but I can't come to those hours. Let's figure out a day and time that works, and I'll do my very best to work with you on that. And we can have an additional office hour that doesn't necessarily need to be in person. If you really just can't do that for whatever reason, you can, we can set up have a virtual meeting, and that'll work too. So definitely want you to have access to your instructor if you're needing help, or need to be able to talk to me about something. Okay, let's swing back over to syllabus. All right, so the next main section is the course materials. Is sort of the meat of the whole walkthrough we're going to do here. So the primary thing, and sort of giving it away right off the bat, of what kind of course materials you'll need for a programming class. Since you're all people who have taken a class before, I'm sure you're well aware you're going to need to know, well, A, what programming language are we using, right? And B, you're going to need to have like a text editor so you can set up your development environment. So I have a whole page devoted to our development environment setup. So let's go ahead and just click on that and head over that direction. All right, so here's my development environment setup page. If you took CSCI 20 with me, then this is going to look real familiar, except for the language we're using. So at Butte College, we actually, all of us in the computer science department for this class use C++ as the language that we use to demonstrate the concepts in the class. So I'm no different. The primary reason we use C++ is because that is the main language that is used at Chico State. And so often our students transfer from our program into Chico State's program to continue their education. And we want to make sure that you have a firm understanding of that language, so you don't walk in the door there and have to learn all the new stuff you're going to learn and a whole new language that you've never seen. So that's kind of one of the main reasons. It's a really good language. It's been around for decades and decades and decades, and it's kind of the bedrock language of several systems. I do want to emphasize this right now, that though I am going to be using C++ for demonstrating those concepts in the class, this is not a C++ class. And you'll often hear me say that over and over again and post about it in our forum, but my goal is not for you to walk out of the class and be like some kind of C++ expert. My goal is for you to learn the concepts of the class. It's a computer science class. And so those computer science concepts that we cover in the class are pretty language agnostic. It really doesn't matter, because those same concepts exist in all these other languages. And so I will teach you C++, and indeed there are going to be some times when I can't avoid it and we're going to have to get a little bit into the weeds. But by and large, I am much more interested in just talking to you about the general concepts, and then I will show you how you can do those concepts or implement those concepts in C++, to be able to kind of show me that you understand how it works. With that said, I'm going to be really prescriptive about the specific compiler that we use and the specific version of C++ that we're going to be using. So I have it written down right here. This whole section is telling you. So for all of the work in the class, I will be evaluating the work that you submit using the GNU compiler collection, or more commonly we call GCC. And Specifically, we'll be using C++11, which is a pretty old version of the language. Again, not a C++ class, so I just need a version that's nice and stable and can easily demonstrate all those concepts, so that's exactly what we're going to do. So I have walkthroughs in here, and we're going to continue on this page about how to get this sort of development environment set up on your system or however you want to set it up. But I do want to just clarify really quick that like need to have GCC, need to have C++11 for all your work. And that's what everything's going to be graded again. So make sure you're getting that set up correctly. Um, you're probably familiar with how to set up a development environment since you've already taken one programming class. So you might know this already, but there's kind of two choices. You can either do it on your local hardware that you have. So if you have a personal computer, you just want to install everything on that computer and do it that way. Honestly, that's the preferred way in my opinion. If you're planning on being a professional, like that's still what professionals do. So it's kind of like a good way to do it. The other option is if you want to use a basically an emulated environment, so something you can run through a browser where you don't actually control the development environment itself. It's usually being hosted somewhere else, like on a different server. That's another option, and there are reasons why people might choose that option. So we'll walk through both, but we're going to start off with the personal computer setup, which is where you have your own computer and you're going to install and run everything locally on that computer. And that's what this whole section right here is talking about. And so I've kind of broken it down into how to get and install the GCC compiler on the three main operating systems that are available today. So I start off with Windows, which is what I expect probably most students have. I have a link here to MinGW, which is actually the minimalist GNU for Windows package. It basically is the way that you can run GCC, excuse me, on a Windows computer, which is a little bit weird since that particular compiler was originally built and distributed as a Unix-based system, which Windows is not. So MinGW is sort of like the tried and true way to kind of get that system available on Windows. I have a whole walkthrough that I built in. It's a separate separate video that I posted in my YouTube channel, walking through how to install it, configure it, and get it all set up perfectly on your Windows machine. So that's what this link right here is. I strongly encourage you to just watch the video and follow along, and that'll get you completely set up with having MinGW set up on your Windows machine. If you're on a Mac, I have a separate video that I went ahead and built for you that is right here. You can just click on that and it'll take you over there to YouTube. And that is, again, complete walkthrough of how to set up and get everything with GCC configured on your Mac without having to, go crazy. It's a little easier on Mac, especially if you use the Homebrew package manager. Again, I explain what that is in the video. So strongly encourage you to watch those two, or watch one of those videos depending on what operating system you have. I don't have a video specifically for Linux, and that's because there are so many Linux distributions out there. I couldn't possibly make a video for all of them. And also, frankly, if you're running on Linux, you probably don't need my help getting GCC installed. And actually, to be perfectly honest, it's probably the easiest way to get it because you could just pick whatever package manager du jour you're using and just install it that way, and it's pretty easy to do. I do have a quick link over here to a website where they actually walk through it for Ubuntu, which is a really popular distro. So if that happens to be your thing, here it is. But I even have a note here, like this is just one of the many distributions available. I'm sure you probably don't need my help, but if you do, feel free to reach out. I'm happy to help. Beyond just the compiler, you're also going to need a text editor to be able to actually, edit your text and write all your code. There are many, many options available to you. I'm listing out about 4 or 5 of them here that are really popular ones. Again, all of the stuff that I'm talking about here is free. So the C++ compiler that we're using is free. The text editors I have listed here are all free, so none of this costs any money to you. You can just pick whichever one makes sense for you. Well, compiler, pick the one that I told you, but text editor, I don't really care. You can pick whatever you want. You're going to see me all semester long using Visual Studio Code or VS Code because it's arguably the most popular text editor on the market and has been that way for, I'm going to say, 10 plus years. But these other options have been around for a long time. There's lots of good choices here. So again, I'm not going to bore you with the details. pick your poison, and you're off to the races. You probably already have one that you feel comfortable with. If you do end up choosing VS Code, I will kind of do a little shameless plug here for this other video that I have where I showcase how to set up VS Code for C++ development specifically. It's a pretty good video, not just because I show you how to get it configured with C++ and MinGW, which is what you're going to see me do in the video, but also just how to configure VS Code to work really well for C++ development. And I show you just a lot of little tips and tricks in VS Code that I've noticed that people don't really talk about that much for some reason. And so it can really be a good video for you if you're interested in getting your dev environment really nice for the kind of work you're going to do in this class, and really any kind of C++ development you're going to do. Okay, if for whatever reason you cannot or don't want to have your development environment be on a local computer that you are in control of, I have two options here for you that you could use for doing sort of like online development. In particular, I would say if you are using a Chromebook as your primary machine, that would be a really good reason why you would want to do this. Like you could also just be like, I don't want to do it because I don't want to do it. But if you're using a Chromebook, I would say don't try to install all of this tooling on it. That's not really what that machine was designed for. It really wasn't designed to do like those kinds of installations. It was meant to run everything in a browser. So that for that one, I would say you kind of really just need to do the online development. But if you just don't want to put the tools on your machine, this is the other option. I have two options here for you: GitHub Code Spaces and Cloud Shell. Code Spaces, it would be my strong preference between those two choices, not because it's like necessarily superior. I haven't been to Google Cloud Shell in a while. The last time I've used it, it was fine. But the main reason I think Code Spaces is probably the better choice for you is that, again, if you're at all interested in doing software development professionally, or even just having your own hobby projects you want to work on, having a GitHub account is really just like a good idea. It is, if you're not familiar with it, it is the world's largest online repository for open source projects. Tons and tons of projects are hosted there. And Codespaces is a feature that was added several years ago, where basically you can create an entire development environment that it looks identical to Visual Studio Code because it's owned by Microsoft as well. That will let you do that entire deving experience in a browser, right? So you can literally just spin up, it's really just a container that's actually spinning up in something that looks like almost identical to Visual Studio Code. And you can pretty much do anything that you wanted to do in VS Code, you can do in a code space. And so if that is the choice you're making is going to online development, that would be where I would recommend you. If you want to try Google Cloud Shell, I'm sure it's a perfectly viable option. Sadly, those are the only two that I've really vetted at this point. So I would say those are the two that I'm willing to recommend. I'm sure there are others out there, but what you're really looking for a development environment will be something that allows you to have the GCC compiler available to you and allow you to do the sort of text editing you're going to see us doing, and allow you to have access to a terminal where you can execute those commands in some kind of a shell. Right, and so both of the choices I've given you here will let you do that, and they give you a lot of control. If you find something else that works for you, maybe let me know so I can add it to my list. All semester long, you're going to see me writing code in VS Code on my local computer. This might be also a good opportunity to let you know that all of the other lectures you're going to see from me throughout the rest of the semester are actually recordings I've done from a few years back, actually when I used to run this class as a live stream. So in those videos, you actually will see students asking questions and doing comments while I'm lecturing, and then I tried to like answer them. So hopefully that'll be beneficial to you while you're watching them as well. But a big chunk of what I do while I'm lecturing is write code in front of people, and you're going to see me do it all from a local install of VS Code and C++ on my local machine. Okay, I think that takes care of this page. We're moving on. So over to the next tool, that's AutoGrader. So Again, if you've taken a class with me before, a programming class, and you're probably familiar with what AutoGrader is. For those the uninitiated, AutoGrader is a tool that does exactly what the name says. It auto grades. So this is the tool that we'll be using to submit the vast majority of the programming work you do in your class. It will require you to set up a separate account. You should have already received an email from me with the information that you need to create that account. Again, it's a free tool. This is a tool that I created and I manage, so it's just Matt's tool. It's not like something else beyond that. And it is where you will make all of your submissions for the programming work you do. You have a video that you are going to be required to watch this week that walks through how to use AutoGrader, how to use it to make the submissions, and how to do it with your assignments. So I'm not going to go into a lot of detail right now about it. That video will pretty much walk you through everything. And I also have a link right here to the AutoGrader submissions page, which also is basically just a text version of all of the specific steps you need to do to make submissions, if you ever just want to have like a quick reference. Okay. Piazza. So Piazza is another free tool that I require everyone to use. Again, you would have gotten this email earlier on, which would have told you the Piazza course I've already created for the class. And Piazza is basically just a question and answer tool. So it's basically the space where I'm going to let on an online space where everyone in the class will be able to ask questions and get answers to those questions, either from me or from other folks in the class. It's a really fantastic tool. I've been using it for many years, and even though we will be meeting in lab and we'll be able to kind of talk during the lab, I'm still always going to encourage folks to push questions into Piazza because it's a great platform for, when a question comes up, you're often not the only one who has that question. And so once it's posted and it's available for everyone, everyone can benefit from the answer. So you're often going to see me push or request you to push things into Piazza, especially if you just email me or message me through Canvas inbox like a question about the curriculum. I'm almost always going to be like, put this in Piazza, please. And again, there's going to be another video that you have to watch that kind of walks through the entirety of how Piazza works. So if you're not familiar with it, don't worry. That video will show you everything. I'm going to make you watch it, so I'm not going to go too much further beyond that. I don't have a book in the class, so you're welcome. No extra cost for you. I do have some helpful resources that I will post up every week, where it's basically just like a curated list of all of the a bunch of different websites that that review the concepts that I've already talked about in my lecture. But I do want to emphasize again, my lecture is the main place where I deliver all of the content. It's where I talk about all of the things and show you exactly how I want you to, implement stuff. So that's the first place you should be going to get that information. But I do, again, provide those online resources to you to help kind of supplement whatever I'm talking about, because it is good sometimes to get it from a different source. Again, I don't have a book, but I do offer these two free resources if you're interested. I don't teach out of them. I never reference them, but some people do just prefer to read and learn from a book. And so if that's your situation, then I do have two free resources here. This first one is a free book on the fundamentals of C++ programming. It's a very C++ specific book, so this is like a book that is meant to teach you that language. And it's free. You can click on this, and I think I actually just have it hosted inside of my Canvas shell, so you can just download it from there. The other one is a data structures book, and this one is not unique to C++. In fact, it's kind of language agnostic, and it's more focused on just the data structures. And a lot of the data structures that we actually cover in this class are also covered in that book. So if you're interested in that, that's another option. This one, I think you just have to go to their website, and here, we'll even go over there for a second. Yeah, you just come over here, and then you can just download the PDF straight from the website. So that's available to you as well. The college offers up a whole bunch of software that you have available to you. I have a link over here, and it provides that link. I'm not going to go wander around, but if you're interested in knowing how Office 365 and how to get Adobe or Zoom or whatever, then click on the link. This should hopefully go without saying that It's a programming and algorithms class, and so yes, it's a very computer dependent course. And that my expectation is that you have access to a computer so that you can do the work in the class, and so that you not having one or not having regular access to a computer is not going to be a good excuse for can't get the work done. So that is an expectation I have. Communication expectations. Okay, so everything's in Canvas. Everything other than Piazza, frankly. So whenever I need to send information to you, that's like a class-wide announcement, I'm going to send that through Canvas. It's going to send it as an announcement, and that'll get forwarded over to your Butte College email. So that any kind of announcements going to come that way. You'll likely get a couple announcements from me every week. One when I put up new material, and then I usually have like a little reminder that I throw out midweek to let you know, hey, if you haven't started the work, go ahead and start it now. You can configure your Canvas notifications if you want, but if you just leave them the way they are, you're probably good. I make a distinction here between two kinds of reasons why you would reach out to me. So I've kind of talked about when I want to announce something to you, this is how I do it. But when you want to reach out to me for something, there's kind of kind of like a tree that leads one direction, a path that leads one way and the other. And so I'm making that distinction here. So the first one is if you have a curriculum-based question or you have a curriculum-based discussion that you want to have with me, the place that you need to put that kind of information is in Piazza. Right, and I just got done talking about kind of its utility, but basically, if the majority of the times that you're going to want to like push information out to me, it's going to be a curriculum based thing, and it's probably going to be a Piazza thing. So I have some examples about like, of how to complete work or when stuff is due or how to submit the work, or if you had feedback in AutoGrader you didn't understand, or, clarification about the instructions, all of that. That's all curriculum based stuff, right? So like the majority of what you're probably ever going to want to talk to me about is going to be something that you're going to want to put in Piazza. So I really want that to be the go-to place that you for questions or comments, or even if you just want to share an interesting thing that you found like on your own, like that's another good place for Piazza. And again, I have a whole video you'll walk through, talk about it, so that's where that is. Now I'm going to contrast that with, let's say you have something that is not curricular based, right? So that is unrelated to the curriculum at large. That's why I have it bolded and underlined there. In that situation, Canvas Inbox is the way to go. Okay. So I'm just making that distinction. If you're going to ask me a question or you want to start a dialogue with me about something that's not related to the curriculum, then that would be a good opportunity for Canvas Inbox. And so a good example of these things might be letting me know about a personal matter that's going to like affect your status in the class or your grade, or if you want to talk about career advice or whatever. Like these aren't curricular things at that point. Now we're just sort of having a conversation about something that's unique to you specific and not really beneficiary to anyone else. So in that case, I would say yes, Canvas Inbox or my office hours, frankly, would be a good place for that to happen. I do check my Canvas inbox pretty regularly. So again, like I said earlier, if you throw it to inbox, you'll get a much faster response than if you try to use my traditional email. And please don't email me from a non-Butte College email. I mean, if you use Canvas inbox, this just gets around that. But if you are going to email me, make sure to send it through the Butte College email account you have. And if you send it from like your Gmail or whatever account, like I literally won't even respond because I have no way to know if it's you. I stopped looking at my computer screen at 5. Oh, if only. I try to stop looking at my computer screen at 5 every day. So if you reach out to me after that, then you really shouldn't expect a response until the next day. This is the grading scale I use for all your final grades. This is the same grading scale you've probably had in every class of your entire life. So nothing new happening there. Here's the breakdown of the course percentages. So I use a weighted average grading system. I suspect I'm not the first class that does this for you, but just in case you're not familiar, basically I have some categories of work, and each category has a specific weight. So in this class, the top one is going to be my programming projects category. Programming projects comprise 40% of your overall grade, and there are 4 projects in the whole semester. So pretty simple math there. Each project is worth 10% of your overall grade. That's a lot. You don't want to mess up on those projects. Okay, that's big way to have your grade go south fast. Um, the other category I have is assignments. So pretty much anything that's not a project and it is going to likely fall into this category, where you're actually like doing some work and then submitting it to me. And all of that is going to encompass like your programming exercises and documentation, research, all that stuff. That all just goes into a category I call assignments. And that is worth 25% of your overall grade. The next category is quizzes. So this is an interesting one. I kind of mentioned it a minute ago. So because it's a hybrid class, the quizzes is going to be the opportunity for me to actually assess you more formally in the class. Now, I don't like giving out midterms and finals. Honestly, I don't like them. I don't think they're super great at evaluating people's understanding of things. So I've opted for just a bunch of small quizzes. So basically every week you're going to get a very short quiz from me. Almost every week you'll have at least one. You might even have some weeks where I have more than one. Maybe I'll do one on like on a Monday and a Wednesday. But those quizzes will be administered in lab. So during our lab time on Mondays and Wednesdays, that is the only time that you're allowed to take a quiz. Okay, so these are not online quizzes. I'm trying to emphasize that now. They are not online quizzes. You could only take them in class, and you can only take them for a very short period of time. All right, so I'm trying to be really prescriptive about that. You really can't miss lab time because that's the only time you can do those assessments. And my current plan is that I will likely do that only on Mondays, unless I have some reason that I need to do a quiz on a Wednesday. Most of the quizzes will likely be on Monday, right when you walk in the door. So at the beginning of class time, that's when we'll be doing the quizzes. Quizzes are really kind of a review of a concept that we've previously done. So I will introduce a concept. We'll have had it for about a week. And then the following week after that is when you can expect to have a quiz on it. So the idea is that this is information that you've had and you've practiced and you've actually turned in material on it. So my hope is that you actually understand it pretty well at that point. And they're short and they're usually multiple choice. And so, yeah, add up all the quizzes. That's 25% of your grade. The last category is the Piazza post. So every week I will have every week you are responsible for posting something into Piazza. And this is to basically track participation. Even though it is a hybrid class, it is also still considered a online class, which means that I am required, frankly, to um, check for regular interaction and participation in the course. And this is just kind of how I do that. So the Piazza posts, there'll be an assignment every single week where you can either post up questions during the week about the material. You can answer other students' questions to help them out, and that again, that will count towards your fulfilling the requirement. And then every week I push up basically a weekly discussion topic. I try my best to relate it to the kind of the concepts that we're talking about in the week, but it's usually like reading an article of some sort. And then you can make some comments about that. And if you do that, that also will fulfill the requirements. And I'll talk a little bit more about this in a little bit, but that's all of the Piazza posts in the class. If you add them all up, that's 10% of your grade. So that's all of the percentages and how they're broken down. If you're not 100% sure about how a weighted average grading system works, I have this page here called Calculating Your Grade. Go there, and I have like a stupid number of videos that explain it and articles explaining it. It's probably overkill. It's definitely overkill, but if you ever want to know, I think the first video is probably the best. It's kind of a fun one. Viewing your grade. All the grades are going to be in Canvas. So regardless of wherever you submit the work, everything comes into Canvas. And so that's where your grade is. You'll push things. So even if you push something into AutoGrader, which is where all your programming work or a lot of your programming work is going to go, in the end, I'm going to just take the grade that you get from AutoGrader and it's going straight into Canvas. When you post stuff into Piazza, I evaluate at the end of after the due date, and then I just push the grade into Canvas. So that's always the place you go for your grade. Due dates. So I would have explained this already in the first message to your email, but just to re-emphasize that I use a sort of modified weekly schedule, except for the first week. The very first week is the weird week where we'll do things in a kind of a weird order. After that, really, the schedule will be this. Every Thursday, I will publish up new material. Every Thursday, bright and early, 12 a.m., new material will become active. The next module becomes active, right? You will have then till the next Wednesday, the following Wednesday after that Thursday one, and that's when most things will be due. So usually you have a literal week to get everything done from the time that it opens and the time that it closes. Wednesday at 11:59 is when I usually have everything set up. The one exception to this, of course, is the quizzes, which you can only do during lab. And my plan right now is to have pretty much lab be when Monday lab will be when that always happens. So that's the beginning of lab time every Monday. Okay, so that's the plan. Um, the only exception to that will be projects. So projects, there's only 4 of them. I usually give you at least 2 weeks to get those projects done. So from the time that it opens on a Thursday, you can see there'll be a 2-week window before the the actual programming work will likely be submitted into AutoGrader. So just so to let you know, like it's not like that for everything, and they're all the dates are clearly marked in Canvas. You can always look at Canvas's date system to see like when something is actually due. It's all in there. All the times are in Pacific time, so yeah. If you're taking this online, I guess I don't know how you would do that. You're all in the Pacific time zone, hopefully. Late work. The most important part of this whole little blurb here is the sentence that I underlined and bolded. I do not accept late work. And it's because I'm a big, mean guy. No. The main reason I don't accept late work is because it's actually related to the schedule that I have. So, like I said, work will come open on Thursdays. It'll be due on Wednesdays. Thursday of every week is usually when I start grading the work that was due from the previous day, really. So my goal for most weeks is that you will have a grade for the stuff you turned in on Wednesday by some point on Thursday. I try my very best to give you a very fast turnaround on your assessments, along with a lot of feedback about what went right and went wrong. But the other thing that happens after the due date passes is that I will push up either separate videos that walk through all of the homework that was due the previous day. Or I will have those walkthroughs embedded into the actual lecture itself. So one way or the other, I'm going to give you the answers basically to what I wanted you to do in the previous week. And I do that because I think that there's a lot of benefit for you as a student, whether you got 100% or you got 0%. Knowing how I wanted you to do the work, I think is very helpful for you to learn the material and also kind of learn the expectations I'm putting on you. And so I can't really do that if I'm accepting late work, right? So that's kind of one of the main reasons why I don't accept late work is just that if I'm accepting late work, then I can't give you the answers to like things that have already passed. And I think those answers oftentimes are what helps students understand like concepts that they were struggling with, right? Or understand how to implement things that they were struggling with. So that's why I do that. Now I do have a note here, obviously, life happens. I get that. So if you have a life event that is outside of your control that prevents you from getting stuff done when it needs to get done, please just message me. Just send me a message, preferably through Canvas inbox, and let me know what's going on. And so I have some examples here. Obviously, like you family member passed away, environmental disaster, you get hurt or sick, or these are things that you can't control. If you tell me about those things, like I will do my best to accommodate those sorts of situations because I don't want you to get punished for something like that. Okay, so it's kind of a balancing act. Make sure you're being held accountable for doing your work, but also life happens. I get that. So please reach out. Okay, how to succeed. So these are just some pieces of advice that I'm offering you to be successful in the class. I want everyone to do well in the class, and I do sort of fundamentally, assume that everyone is trying to learn the material. Like you want to know the stuff that we're talking about in the class. And so this is just my advice on how to best to do that. I'm not going to walk through every single one of them. Some of them are more obvious than others. But I will kind of re-emphasize these first couple here, which is like, watch the lectures. I've already said it a bunch of times. It is the way that I deliver all the content. And if you don't watch the lectures, honestly, I don't know how you think you're going to do well in the class because you just won't know how I want you to do things. Even if you thought I'm a C++ genius and I can just Google it or whatever. Like even if you thought that, Google's not going to tell you how I want you to do it, right? So like you really have to watch the lectures to understand that material. So don't watch the lectures. Um, don't wait till the last minute to do the work. Anybody who's taken a programming class with me will tell you that is like the number one thing that will kick your butt is waiting until like the day before something is due to start working on it. That is a great recipe for getting a bad grade. Um, Especially since you have AutoGrader that provides you that instant feedback. What that really ends up meaning, and so it's kind of a love-hate relationship with AutoGrader because hey, you're getting that instant feedback. You automatically know you're getting 100%. Super great. But when you don't get 100%, it's going to tell you something, and you might not understand why it's telling you you did it wrong. And you're going to need time to be able to like make a post in Piazza and ask the question and get some responses, or go to office hours or ask in lab or whatever it is you need to do. And if you've only given yourself like a few hours between when you started the work and when it's due, you've basically left yourself with no time to get 100%. And again, I don't accept late work. So you've kind of put yourself in a no-win situation. So don't wait till the last minute. Get it done. I'm going to talk more about this here in a minute, but yeah, AI. I have a pretty much a zero tolerance policy with AI. So you're not allowed to use AI to generate any of the code that you submit to me in the class, not one little bit of it. Right. So I'll talk more about that here in a minute, but yeah, don't use AI to generate the work. This will definitely get you a zero. And hopefully, and I'll talk about it more here in a minute, but like, I am trying to evaluate your understanding. I'm not trying to evaluate an LLM. Like I don't care about what the LLM thinks. Um, a lot of this we're going to talk about more, but I have a grading rubric for everything. Be sure to review the rubric. AutoGrader's attached to the rubric, so for a lot of this stuff, it sort of automatically does it for you. But it's not all AutoGrader, so you should watch the rubrics because that tells you exactly what I'm wanting you to do. Like it kind of spells it out for you. And the rest of this, I'll let you read it. Also, if you've taken a programming class before, you'll be familiar with the idea of it being kind of a frustrating experience when you can't get something to work the way you want it to work. Just know that I'm trying to get you to pass. Like I want you to do well in the class. And so I don't put things in front of you that can't be done. Like it can be done. You'll take work, and I do expect you to put in the work, but if you're willing to put in the work and come in and ask the questions and do what you got to do, I'm here to help. That's what I want you to do well. So don't give in to the frustration. Ask for help. Okay. The other one here is a little link to the alumni page. I'm going to quickly talk about this because there's actually an assignment attached to it in the first week. But at the end of the semester, I will be giving out a little survey of, basically just some feedback that you can give me about how the course went. Usually it's like, what went well, didn't go so well. But one of the questions on that survey is advice that you would like to pay forward to future students who take this class. And so when I get that advice, I keep it in a page that I call my alumni advice page. And we can just click on it really quick right here, go over here in a new tab. And this is just a uncurated list of a whole bunch of the advice that previous students who have taken this course are offering you, a student who is just entering into the course. And these are students who have taken my specific class and have dealt with my nonsense, right? That my setup. And this is their advice on how to be successful in this class. Okay, and so we actually have an assignment attached to this this week, so I'll talk more about that. But this is sort of the page that outlines all of that, and that's where that came from. Okay, academic policies. So there's a lot of different policies that the college has. You can click on this link and go read all about them. The college just recently revised their website too, so I had to update some of these links. A lot of them didn't work anymore. So this is the best one I can come up with, where it kind of showcases most of the campus policies and the student expectations and the conduct and rights page. So probably a good place for you to know from a college-wide perspective, like that, not just from my class, but like the whole college, like what they kind of expect from our students. This next section is the course academic integrity policy. So this is my policy in this class about academic integrity. So if you're not familiar with what academic integrity is, that we're talking about cheating. The short answer to this is don't cheat. Like don't cheat. And then what I'm going to further elaborate on here is like, what does it mean to cheat though, right? So like, I could say don't cheat, and that seems obvious, but like if you don't know what I mean when I say cheat, then that's kind of a mean thing to say to somebody, right? So what I mean by it is I want to make sure that the work that you're submitting to me is coming from you and is a demonstration of your understanding of the material from the class. And that's really, I mean, every teacher sort of has this sort of dual job that they're doing where they're showing people stuff on one hand, but then they're also assessing whether or not people actually know the stuff that they showed them, right? And so it's kind of this two-tiered problem, two-tiered thing that you're doing as a teacher. And so for me, the second tier, the evaluation portion of it, really is coming from this idea that I gave you some knowledge, and I want you to now kind of tell me that knowledge back, so I know you know it. So there's basically three sections that I've identified, three kind of circumstance, if you will, that I've outlined in this section about what I think of as cheating, right? Something that would violate my academic integrity policy. So we're kind of going to walk through this really quick. The first one is sort of the classical thing, which is actually formally called academic collusion. And it's basically when like two people basically just like one person just like copies off of another person and they both submit pretty much exactly the same work to me. I don't even know why people do this. It does happen. I wish it didn't, but um, where basically two people are turning in identical work. So when I find that, I basically both people get a zero, and it's really easy for me to spot. This is sort of a problem that has been solved long ago for teachers, so I really strongly don't advise doing that. There will be opportunities, obviously, for you to collaborate with other people, like in the lab or on Piazza and whatnot. But the expectation is that when you go down to sit down to do the assigned work in the class, that you're doing that on your own. You're doing it just you, not everyone else, right? And so that's where this becomes a problem, is if you're just taking what they did and just pasting it in somewhere and then being like it's a thing now, right? That's cheating. The next one here is basically, let's say you had a buddy who took this class a few years back, and and you were like, hey, I don't know how to do the assignment, and they're like, sure, here's my submission from like 2 years ago, and then you're just like, great, and then you just submit that in. Right. Okay. Well, that's straight up plagiarism. Like, is what that is. It's like the definition of plagiarism. It's presenting other work that as if it was yours, even though it's clearly somebody else's. All right. So again, it's very easy for me to tell when this happens. I use AutoGrader. I have a massive repository of all the submissions I've ever gotten in the entire time I've been teaching, so I know what every submission looks like. So if you submit something that's basically a duplicate of somebody else's work, I'm gonna know real quick, and then you should just expect to get a zero on the assignment. So that's how I deal with those. The last one is by far the most interesting, I suppose. So the new kid on the block. And that is submissions that were generated using generative AI. All right. And so this is a problem for all teachers now, I guess, as we all kind of have to deal with this. And it's a tricky one. It's a little bit tricky because, and I guess I'll just kind of quickly talk to you a little bit about my general philosophy about AI, because I think it's important for you to know that from your teacher's perspective. So I'm a fan, I guess would be the best way to do it. Very, at the bare minimum, I'm very fascinated by it. I do think that it is an incredibly powerful tool that has the potential to be very helpful for people to um, be productive in doing whatever it is that they're doing, right? It's an extremely helpful tool for productivity. I myself use it. Again, I've been a software developer for a long time. I've been using generative AI systems now for about 5 or 6 years, um, to help me with a lot of my own like programming projects and consulting work and things like that. Super useful, super helpful. Has made me a faster, more productive programmer, hands down, no problem. Um, the problem that we have here is in an educational space, and especially in classes that we teach at the community college, which are literally these like first and maybe second semester programming classes where you are literally learning what it is to be a software developer. Like you're learning these fundamental, like base level things, right? You are not a professional software developer already, right? If you were, I'm not sure why you're in my class, right? So the idea is that you're kind of a new person to this domain, this skill set. And in those situations, AI, in my opinion, is like a hindrance because what it's really doing is it's taking away your ability to think, your ability to actually learn the material and understand the material. And a lot of what programming is, and this is true in a lot of STEM, but a lot of what programming is trial and error. Is literally just trying something and having it not work correctly and then having to like think about why it didn't work and then come up with a solution. And those are skills that you are learning in this class and a lot of your fundamental classes. And it really doesn't matter if it's programming. This same philosophy could be applied to pretty much any kind of technical discipline, frankly. You could be doing this as a, like, I don't know, like as a person in like food and you're like a cook and you want to like learn how to make cook food better, right? Like it's a technical discipline. um, so if you already know the skill very well, AI is kind of like being able to brainstorm with somebody who's also really smart and knowledgeable, and you as a person who already understands the topic can have a very intelligent high level conversation with them about it, and you can discern whether or not it's giving you good or bad information, right? Because you already know, because you're skilled in that area. Since you're not really skilled in that area yet, you're kind of learning that stuff. AI is just telling you stuff and you have no reason to doubt it, right? You don't really have a way to know if it's giving you good or bad information, right? And so this is the problem I have with it, is that it basically just prevents you from being able to like learn the material and like think for yourself and like gain those skills so that you can actually be a good professional programmer on your own, independent of it. So all that said, I have a pretty strict policy about it. So if I receive a submission that appears to have even partially generated by AI, so I want to emphasize this, is that like sometimes I'll get submissions from people and you know, I'll be like, this gets, and it gets flagged for AI, and they'll be like, well, I only used AI for like this first like couple lines, and I'll be like, yeah. So that means that those couple lines, I don't know if you actually understood that. You just took it from some other place, right? I have no way to differentiate like what percentage of it you did versus some other system, right? So you need to write 100% of what you give me. Okay, that I'm just trying to be as clear about that as possible. So if I get a submission that has even been partially generated by AI, that submission will get a 0. All right. Now the way I handle that is, because you might be going like, well, how would you know? What if you accidentally flag me for AI even though I didn't use AI? First off, more than almost any other teacher you're probably ever going to have, I have developed systems to help me identify AI. I've been using it for a long time. This is a genuine fascination of mine. I've built my own fairly robust systems for identifying it. And also, frankly, your beginning programming students, like it's not that hard for me to look at code written by second semester programming students and compare it to what ChatGPT kicks out and to know like which one is which. It's just not that hard. But I have a lot of other systems I built to do this. Okay. But on the off chance that I am wrong, what'll happen is you'll get the 0, and then I'll let you know, hey, you got a 0 and it was flagged for AI, and then you'll have a week from the time that you submitted it to me to come and talk with me about it during my office hours, or if you need to schedule a time, I guess that's fine too, right? And the idea is that you're going to meet with me so that we can, so we're basically going to sit down and we're going to be like, first thing I'm going to ask you is, did you use AI at all? And if you say yeah, well, I'll be like, okay, well, that's why you're getting a 0. But so you need to not have used AI at all. Also, you need to demonstrate that you understand everything that you submitted to me, right? So this is not just like a purely like, well, I had AI, but I understand it, or the other way around, I guess. So that's the thing. If you can convince me that, yeah, I didn't use AI and I understand everything that's in here, then I'll just assess the assignment. So I'll regrade it and you'll have a grade, and no problem, right? But if you don't, so either if you just don't show up, you never reach out to me, then you just get the 0. Or if you can't convince me because it's pretty clear to me that you did use AI still, then you still get the 0. And so that's just how I deal with that setup. Um, those are the 3 main categories. I really don't know of anything that falls outside of them, so those are the ones we're doing. The last part of the policy is that if I get 3 of these throughout the semester, on the third one, this is now a pattern. It's not like just that one time I whoopsied. Like now you're doing it repeatedly. So on the third one, I actually will make a submission to the dean of student services, who handles disciplinary actions for plagiarism and academic integrity violations. I don't want to do that. I don't like doing it. It's a bunch of paperwork for me and you, and everyone hates it. So the end result here is don't cheat. Just don't cheat, and this won't be a problem for you. The vast majority of my students, this literally never comes up. Right? I do usually have at least a couple, and I really hope that this is a semester where I don't have any. But like the majority of students, this is not a problem. Okay, you might even have one ever, but like three is usually we got a problem. Okay, all right. Enough of that. It's a yucky topic. I don't like talking about too much, but I do want to be clear about it. Okay, course attendance and withdrawal policy. Are we done with this yet? Can we be done? Federal law requires the participation to get financial aid. So basically, I am letting you know what my expectations are from you for considering for attendance. Really, I use turning in work as the way I gauge whether you're actually attending my class. Since it is a hybrid class anyway, right? I am going to basically be requiring you to come into my lab, but I'm rarely going to be actually taking attendance in lab. I probably will for the first couple of weeks. After that, frankly, you're all adults. I expect you, if you don't want to be in the class anymore, you're probably just going to drop yourself. First couple of weeks, I will take some attendance and see who's here, because I get it. It's the first couple of weeks. People are deciding if they're going to stay or they're going to go, or, oh, this guy's into YouTube, or I don't like his AI policy, or whatever. There might be some reason you need to leave. And if you don't drop yourself, then okay, I'll do it for you. All right. But after that, I do sort of expect you to do this on your own. I will probably check in again around the halfway point and maybe like near the end of the class, just to see if there's anybody who's kind of just checked out but they haven't dropped yet. But that's just sort of how I handle it. It is your responsibility to drop yourself if you don't want to be in the class anymore. I don't want anybody to drop, but like, it's college. Of course, accommodations. If you need an accommodation, please let me know. You can reach out to me through the inbox or my office hours, and I'll do my best to accommodate. I try to be as accommodating as I can. Just let me know. Student services. There's tons of services that the college offers. I have a link here to a page where they like list out a ton of them. Definitely give it a click, give it a review. I'm not going to do that right now, but there's a lot of services the college offers, and so take advantage. There's two in particular that I like to call out directly in my syllabus. The first one is the Center for Academic Success, or CAS. If you've been a student at the college for a little while, I'm sure you're aware of it. But CAS, if for those who don't know, is free tutoring for everybody. I am a big fan of CAS. I think that the work that they do there is great. I myself was a tutor when I was an undergrad, so I have a kind of a special place in my heart for tutors. I know that this next semester we should have at least a couple of computer science tutors. There are actually some people who I recommended from the previous semester, and so just so you know as well, like if you're doing well in my class, there is a very strong possibility that at some point I will reach out to you and say, hey, are you interested in being a tutor for the next semester, and you not have a job for the next couple of semesters. So I strongly encourage you all to sign up, whether you think you're going to need the tutoring or not. Just go sign up. It's a free class. You just sign up for this Edu 310 class. It's free. It doesn't cost you anything to register for it. And then if you ever do need it, you're hopping right in. I even have a little link over here to this CAS services thing. I think that's how they now are setting up their whole like how to find a tutor and schedule and stuff. But all this information is already outlined on their webpage. So just click on that and that'll take you there and you're all set. The other service I like to mention to everybody, because I don't think that every student knows that the college offers it, is our student health clinic, and specifically our mental health offering. So our student health clinic offers mental health services to all Butte College students who are enrolled for a 4-credit class, which you are in this class. And if you've paid the student health fee, then you're eligible for it. Lots of reasons why people might need this service. I'm a big proponent of getting help if you need it, right? And the college does a good job of like offering up a lot of services. This is an easy one for you. This is a hard class. In case I haven't said that already, it's a hard class. I know it can be kind of stressful for people, and sometimes that can cause them to like kind of not want to do anything else, or they kind of like have a hard time dealing with that. hopefully you'll talk to me, but here's another service available to you. So take advantage if you feel like you need it, it's there for you. Okay, and the last bit is sort of some boilerplate stuff, the miscellaneous disclaimers. Just basically just letting you know this is where my syllabus is, and if I ever change it, I'll put an announcement out. Don't suspect I'll change it. Luke is our department chair. This is how you reach him. This is the dean's office chair office information if you ever reach out to them. So that's there it is. We did it. We went through the whole syllabus. Woohoo! Okay. I don't even know if I did that fast. I feel like I probably did it slow anyway. Let's go ahead and jump over into sort of like how this class is going to work week to week, and especially this next week, like how things are going to work. So I'm going to click over here into modules. This is the button you're going to click pretty much every time you come into my course shell, unless you just want to go over the syllabus. Maybe you're having a hard time sleeping. That's a good place to go to read and fall asleep. Pretty much all those links you saw in my syllabus, I have a link to them right here directly, right? So you don't have to go hunting around in the syllabus if you want to know what my office hours are. They're right here. Also, the thing for the using Piazza and autograder submissions, all that good stuff is here. We're going to scroll down a little bit. Data structures is a module that you will see get populated as the semester progresses. As we get past some of the major data structures in the course, you'll see things populate there. You'll see me talk about that more as the semester begins or continues. Right now, there's nothing there, so don't worry about it. Excuse me. Next section, this is going to be kind of the main thing for this week. So this week, the first week of the class, your goal here is really just to get your development environment set up and do like some real quick, easy programming class stuff. Like my plan for you is to mostly get your development environment set up and just some basic review of some things that I kind of expect you to already know, to help you kind of hit the ground running for week 2. So here's a link to the lecture you're already watching. You don't have to do that, but if you ever want to come back, that's how you can get to it. And this course overview module is kind of like my gatekeeper, meaning you won't be able to access any of the subsequent lecture modules until you have completed everything in this module. That's why it says complete all items right here. And you notice that right now I have not completed all the things. You can see that these all have been checked off, but this one hasn't, right? So that's why right now when I scroll down, you can see all of this is grayed out. I can't access the first week's, the first lecture homework because I haven't completed the actual course overview module. So that's just sort of letting you know right now, that's the first thing you're going to have to do. And you're like, how do I complete it? Well, I'm glad you asked, fictional student in my head. The way you're going to complete this is, and I'm sorry, I'm going to just say I'm sorry right up front. I'm going to make you watch a bunch of videos. And I'm sorry, I really am genuinely sorry for doing this to you. It is the only week I do it to you, is this very first week. But there's some kind of just preliminary stuff that I need you to know how to do. And so I'm going to make you watch some videos and take some little quizzes to show me that you actually know what you're doing and like you're ready to take the class. So first video you're going to watch is the command line interface for beginners. My expectation is that you already know how to use the command line interface, but I have noticed that sometimes even though people are in a second semester class, they don't seem to know how a CLI works. So I'm going to make you watch my CLI video, and that will kind of walk you through what a CLI is and how it works. And you're going to have to answer some questions along the journey, but that's what this is about. The next one is the AutoGrader submissions walkthrough. Again, if you've never used AutoGrader before, this is that video I was mentioning before where I walk through the entirety of how to use AutoGrader and how to use it to submit work in the class. I need you to know how to do that, obviously. So this is like a required walkthrough. Just I need you to know how to do this. Same thing for the Piazza overview. It's just a video that shows you how to use Piazza, and I walk through all of the features of Piazza that we're going to use in the class and how you can set things up, and so to make the most out of that tool for you. So like those are the 3 videos that I'm requiring you to watch. And again, I'm sorry. I know it's a lot of videos on top of this one. It's the only week I make you do it. So just muddle through them, and I'm sorry. I do want to make mention of how you got to get through these. So they are hosted in YouTube, but you don't watch them in YouTube. So these are all my own personal videos, but I am using a different system to assess them. So when you click on them, like let's say I'm going to click on this first one, right? It's going to open this up. Notice how I'm not in YouTube. It's actually going to open up this little thing that says load command line interface in a new window. You click on that, and that's going to actually open up a completely different tool. I think it's called like WeVideo or something like that, right? And you're going to watch the video here. Now, as you're watching the video, periodically the video is going to pause, and then a little quiz thing will pop up, and it'll actually, you have to answer those questions, and the questions will be about the things that were just covered in the video, right? You have to get all of the answers correct in these videos in order to pass and have the checkbox work when you get back over here. I want to come back over here, I guess. Right, so that's how these have been checked off, was that I actually had to watch these videos and I had to answer all the questions. You can't jump ahead in the video. You can't like skip the whole video and try to get to the end and just like say, hey, I did it. Like, you need to watch the video. You need to answer all the questions. Okay. I did at least let you change the speed at which you watch the video. So if you click on it, it'll start playing. I want to pause it really quick, right? And then you can click down here in the settings. You can go up here and you can change this to like 2x. So now you're watching it at double speed, right? But that's like kind of the only way you can really go through it fast. I need you to know it, but I will let you watch it fast, but I do need you to actually show me you actually understood it. All right, so get that done, get all these check marks done, and then you're done. Now notice how those are just the videos. There's also a quiz. So this is like my course overview quiz. This is basically a quiz about everything I've just talked about in the syllabus, more or less. So if you were paying attention in the syllabus, it's all multiple choice. Answer the questions in the course overview quiz. You can take that quiz as many times as you want, but you won't get a check mark until you get 100%. So take it as many times as you need to take it until you get 100%, and then that'll check that box for you. The last thing on here that you have to check off, and that's the one that I haven't done yet, is the development environment setup. So this is just that development environment page. You just click on it from here. It's this page. It's just my way of saying, hey, have you set up your development environment? Because you're definitely going to need that to do like a humongous chunk of the work in this class. Once you have done that, just come down to the bottom and click this button that says mark as done. Check, it's done. Let's go back over to modules. Scroll on down and notice how now, look, all the items are completed. That was the last one I had to complete. So everything else is done. You get the green check mark, and as soon as that happens, I come down here and oh, lo and behold, all of this is available to me now. So now I can see all of the work that was done that's available to me for the first week. Okay, so let's go ahead and jump into lecture 1 really quick. So one of the first things I'll quickly talk about is the helpful resources page. So helpful resources is just a page, and you'll see one almost every single week. I have a helpful resources. In fact, if you come down here to lecture 2, oh, I don't have one for lecture 2. Oh, it hasn't published yet. You will see one in there. It's just not there yet. But lecture 1, helpful resources, let's just click on that. It's basically a curated list of outside resources that supplement the stuff that I talk about during the lecture, right? So in here in just a little bit, I'm going to start talking to us about the actual programming in the class. So these are a bunch of things related to how to compile and using CLI and commenting and all the stuff that I'm going to talk about today for my programming perspective. This first one, this programming with standard in and standard out videos, is sort of another shameless plug for me. I strongly encourage you to watch this. I've noticed a lot of second semester programming students don't really know how standard in and standard out work, and they are really fundamental concepts for programming, and it's kind of weird to me that people don't seem to know this if they're for programming students. So I made a whole video just for that. You don't have to watch it, but I encourage you to. I also have tips and tricks in there on things that will probably help you with also just like debugging autograder problems in this class, because it's kind of geared that way. So I show you how to, you can really get super precise with it. So probably a good idea. But you'll have helpful resources every week. Again, the lecture is the primary way, but those are kind of supplementary. And then here's the code that I will publish at the end of this lecture, where I'll have the actual code for the lecture itself. This is the page that hosts it. This is the week. This week is a little different, like I said. So the first week is a little weird. You're not going to have a quiz on the first day. That would be kind of messed up. So our lecture, our first quiz is actually scheduled for Wednesday this week. So you can do on the 19th, we'll have a command line quiz that will become available when the class actually starts. You can't click on this and do anything right now. In fact, here's just a demo that. See how you can't do any. This quiz is locked until literally class starts. Okay. So just FYI, like that's how that's going to work for all the quizzes. And then Oops, I went too far. And then this is the other assignment I want to talk about, which is heed the advice. So like I mentioned earlier, we'll just go ahead and click on that really quick. Heed the advice is, if again, we go back to that alumni page, alumni advice page, this is all the advice that other students are offering you on how to be good in this class, how to do well. So what I want you to do for this first assignment is I want you to review that page, and I want you to select 2 quotes that from that page, and each quote needs to have distinct advice. Distinct meaning like it can't be the same advice. So if one of the pieces of advice was, don't wait till the last minute to do your homework or something, right? And then the other piece of advice is basically somebody saying more or less the same exact thing. Those aren't different. Those aren't distinct. Those are the same pieces of advice. So I want you to find 2 completely different pieces of advice from the previous students. Select 2 of them, and then you're going to write a little thing about why you picked it and like how it might be helpful for you. The way you'll submit the work is you're going to download this submission form right here. You can download it to your computer by just clicking this little down arrow, and that will actually download it onto your computer. And I'm just going to, if you click on it right here, you're just going to see it. It's just going to show it in Canvas. It's not, you're not really downloading it. You're just viewing it. But I will show it to you what it looks like. So this is the submission form. So this is where you would take, like, let's say I wanted to get some advice. So let's say this was the one I wanted. I would copy that and I would paste that right here on this first selected alumni advice quote. Okay. And then here's where I would explain why I picked that quote and how I think it's going to be helpful to me. And then this is where I would go, okay, different quote. This is the different quote I'm going to do. I copy and paste that one into here, right? And then this is where I would explain why I picked the second quote and, how I'm hoping that'll help me do well in the class, right? So this is my opportunity for you to like actually read that advice, because those are people who took the class. It's not just the teacher rambling at you. It's actually some other people who took the class and presumably have their own ideas about what they did to do well in the class. Also, this is an opportunity for me to show you what the grading rubrics look like. I mentioned it before. I have a grading rubric for everything in the class. So here is an example of a grading rubric. Every grading rubric, you can see like this assignment is overall worth 100 points. Right, and you can tell that it's 100 points for as an assignment, and it's letting you know how you're going to get those 100 points. So 10 of the points are coming for this particular assignment. 10 of those points are coming from just using the template, right? So instead of just like you could, I guess, just come up with like a Word doc and then just write your answers directly in there. If you don't give me the actual template that I'm giving you, if you don't push this down arrow and then fill it out and submit it to me, then you're not going to get these 10 points. Okay, it's like I'm trying to be as like crystal clear as possible about like what I want you to do here. So you use the actual template, that's 10 points. You actually grabbed a quote from the list and you copied and pasted it into the form, that's 20 points. You explained the quote, you explained why you did that. And actually, if you're ever looking at these little things right here and you're like, I don't quite understand what he means by that, that's what these longer descriptions are for. So if you just click on one of them, it'll tell you like the submission references a direct quote from the alumni page for the first selected quote, right? It's like it's telling you specifically what it's for. It's like telling you exactly what you are supposed to do to get these 20 points. Okay, so I always encourage you to review my grading rubrics. Like I'm spelling it out for you. It also kind of emphasizes what I think is the most important part of an assignment, because you might notice that the explanations for this are worth 25 plus 25 is 50%. Half of the points for this is literally you just is the explanation point portion of it, right? So that always a good idea. Great. Look at the grading rubric. For this assignment, you're going to upload that document into Canvas, and always remember to hit the submit assignment button. If you don't push this button, I will never see your assignment. I've noticed that sometimes people will just upload their assignment and then they see the little progress bar go across and they're like, oh, it's uploaded now, and they don't push submit, and then they get a 0, and I'm like, yeah, because you didn't turn anything in. They're like, but I did, and I'm like, no, you didn't though. If you don't push submit, I'll never see it. Okay, so that's the first homework that's due this week. This first week. The second one is tip calculator, and I'm actually going to swing back to that after I've gone through our programming lesson for today. But before I jump into that, the last thing I do want to emphasize is when everything is due this week. So this week is the one week that is weird and different than all the other weeks. Like I said on the syllabus page, The due date for pretty much everything is always going to be on a Wednesday. That's pretty much my due date for almost every single thing in the class, except for this week. For this week, because it would be weird to start on a Monday and have everything due like 2 days later, I give you till Friday. Okay, so you have till Friday to get Heed the Advice done, Tip Calculator, and Piazza Post. Okay, so these things are technically going to be, you could technically submit them on Friday, and everything, the next week's stuff is going to pop up on Thursday. So there will be a little overlap this first week. After that, there won't be overlap. Things will get due on one day, and then the next stuff will pop up on the next day. All right, so it'll be due on Wednesday, published on Thursday. Due on Wednesday, published on Thursday. This week is the only exception to the rule because I'm really just trying to get your development environment set up and kind of do some preliminary assignments to get yourself off the door, get yourself moving. Kind of tripping over my words now. The last one here is the Piazza Post. Again, if you're not familiar with my class, so this is that weekly assignment that I talked about earlier. Every week you'll have a Piazza Post assignment. They all say the same thing. You can get the points for this assignment every week by either asking questions in Piazza, answering questions that were posted by other people in Piazza, or you can respond to the kind of weekly discussion topic that I will post up in Piazza every week. I'm looking for substantive posts. So if you just go in there and you're like, somebody posted a question and you're just like, me too, or whatever, like that's not a substantive post. That's not, I don't even know what that is. That's not participation. All right, so I'm trying to be clear about what I mean by this. So in general, a paragraph's worth of posting will meet the requirements, right? And I define a paragraph to be about 3 or 4 substantive sentences. So you actually have to contribute in some way to have this actually to meet the requirement every week of participating. Okay, so that's what I mean. And also, I don't count private posts. You can actually make a private post in Piazza. I talk about it in the video. But if you make a private post, that's fine. It's just it won't count towards meeting this requirement. And I only count the posts that were made for that week. So again, stuff gets published on a Thursday, and then everything's due on Wednesday. That's when these are due, except for this first one. And so between those two periods, so between the time that the last one went up and when it was due, I look at all the posts and activity that happened in that time frame, and if you did these things in that time frame, then you participated. If you didn't, then you got a 0. Okay, so that's kind of how that works. Okay. My goodness, so much stuff. Now that I've done all that, I guess we can jump over into the actual the programming lesson for this week, where I want to kind of introduce the first, like really just your introduction to C++, and sort of some review of some concepts that I kind of already expect you to know how to do. So let's go ahead and jump into that. Okay, so let's go ahead and get started on the first programming lesson for the class. The main focus of this is going to be on introducing C++ as the language. So none of the concepts that I'm going to talk about during this lesson I expect to be new information to everybody. Second semester sort of programming and algorithms class, so I'm literally going to just explain things, concepts that I expect that you have already been introduced to in your previous course, but you might not necessarily have had them introduced for C++. So that's kind of the main focus here, is just sort of intro into C++, and then a little bit of review, obviously, of things that you should already know how to do. So let's go ahead and just start things off. I'm in VS Code, as you can see. I'm going to go ahead and create a new file, and for this programming lesson, I think we're just gonna do a real simple like pay calculation tool. So I'm gonna have make a little application that can calculate weekly pay based on like the number of hours you've worked and how much money you make per hour. So first thing I'm gonna do is go ahead and create a file. I'm gonna call it, I don't know, pay.cpp. .cpp is the extension that you use to signify C++ programs. You're gonna open this guy up. And the very first thing we're going to do is I'm going to talk about the proper code layout in the class. I'm actually going to swing back over to our course module, and you might notice that here in the there's a little section here called example code, and this is just a module where I'm going to put anytime I need to introduce like a specific way to go about doing some programming task, and I need to do it in a kind of very prescriptive way, I'll just put things into this example code module. And so for this week, the very first thing I'm going to have in there is the proper code layout. So go ahead and click on that. And this is basically just the prescriptive way that I'm having you kind of like start every program. And it basically showcases like what pretty much every program in the class is going to, the source code is always going to have as part of it. So what I kind of expect most people to do is, again, this gives a little explanation of what this is, but really just me kind of take this, I'm gonna hit Control C, I'm gonna come back over here, I'm gonna hit Control V, and bam, and I'm gonna hit Control S, and there it is. I have the sort of the beginnings of my program, and it has what is now called the proper code layout. I'm gonna squeeze this over to the left a little bit just so I have enough room. Um, and the main things I want to focus in on for the proper code layout are just really this header block right here. This is a form of documentation. It's a pretty common way that programs get documented, like what they basically do. And so I'm going to demonstrate really quickly for our fake program here, like just what I expect from you all semester for when you fill out your proper code layout header block, like what I'm expecting you to do. So for this one, you almost always are just going to name it the same thing as your assignment. This isn't really an assignment, so like I'm going to call it like, a pay calculator or something like that. Right, but whatever the name of your assignment is what I kind of expect to be there. Your name obviously is what I'm going to put in here. So Matt, right? And then the date that you're completing this. So I'm going to just say what, 8/26. Okay. And then a description, and this part I want you to take a moment to do. So this is a high level description of the program. Okay, so I'm expecting you to actually describe overall what the program does. So a simple program that calculates weekly pay. Okay, so this is that's a perfectly fine description. I'll even extend these out to cover the whole thing. I guess you don't have to do that, I guess, on yours, but this would be a good example of what I would want to see from a proper code layout setup. Again, I mean, I feel like this stuff is pretty easy to do. Just make sure to follow the template. Also, make sure that you put the actual author and date completed in the description, like all these little labels in front. If you don't, AutoGrader will probably kick back at you and saying like, hey, you didn't follow the directions correctly. And also it will complain if you don't actually do this. So like, for instance, if I do a description like, like, I don't know, does a thing or something like that, like that's clearly not a real description of what it does. So you can expect to lose points on your proper code layout every time if you don't actually fill out the layout correctly. So this is a better example of what I would want to see. Actually, I'm going to copy this one more time. And then one other thing I will showcase before I jump into the rest of this is that if you want to get slick about it, you actually can use code snippets to actually preemptively just like fill out the block if you don't want to have to copy and paste it every time. So here I'm going to delete all that. And actually what you can do is I have a snippet already defined called PCL for proper code layout. And this is a snippet that I programmed and put into VS Code. And when you do it, it just automatically fills it out with the information and format it exactly the way I want. And then I'm just going to go ahead and put my description back in there, and then I'll call it the pay calculator. So if you're very interested in doing that, maybe that's a good Piazza post for, and I'm happy to share my snippet so you can build something on your own if you're using VS Code. Okay, the next portion is kind of just like what the rest of the actual code portion is going to be. This is just a library that has some pretty standard stream input that I will talk about more later on in the semester, but for now, just this is sort of boilerplate for you. You're going to need these for the beginning portions of all of your programs. This is like one of the most common libraries in the entire language, so you're pretty much going to use it in every single program. And this is something that I'm prescribing you to put into every program. If you were to Google it or whatever, I'm sure there's people who will be all like, that's not good, you should do it a different way. Yeah, if I was a professional writing like enterprise software, this is probably a bad idea. In your like programming class, this is a good idea. Do it this way, follow my lead. The other part here is the main function. So this is a function. It's not a concept I expect you to be unfamiliar with, but I will take a brief moment to talk about sort of the anatomy of a function in C++. Also an opportunity for me to showcase the different commenting styles. So as you can see right here, this is like a documentation block. This is actually using a block comment. You can see it starts with a / and a star, and then it ends with a / / anything in between between is commented out. And now I'm going to show you how you could do just a line comment, which is just 2 forward slashes. And just like probably other programming languages you may have used, this is very similar. And let's do sort of the anatomy of a function. And this is going to be C++ specific. So in C++, the anatomy of a function goes like this. You start with the return type. Then you have the name of the function. Then you have an open and closed parenthesis. And in between theirs, you have the parameter list. Right? Then you would have a open and closed curly brace after that. I should probably comment this out. Open and closed curly brace after that. And then everything in between, here I'll comment this out, anything in between that will be the body. Okay, so these are sort of the key characteristics of a function in C++, the return type, name, parameter, list, body, and hopefully whatever programming language you were using in your CSCI 20 or equivalent course would have had pretty much exactly the same components, or I probably help if I spell this right, anatomy, anatomy of a function, anatomy, yeah, I'm like way off on that one, and that's because pretty much all programming language, all imperative programming languages are going to have more or less the exact same components. The only real major differences between them is usually sometimes they might have like a keyword or something here or there, but by and large, they're always going to have basically these 4 components to make up any kind of function. They might also change the position of where they're in. So I know if you came from like the Go programming language, then you have noticed that the return type is usually, they actually put it at the end of the signature. If you're using like, I don't know, Python, they might start with the word def or something like that. But in the end, they all have these components, and C++ is no different. So here's the return type. So the main function returns an integer. This is the name of the function, takes no parameters. So that's why it's just an open and closed parenthesis with nothing in it. Here are my open and close curly braces to signify where the body will be. And then C++, at least C++ 11, you're going to have a return 0. That's just like part of the language. It expects you to have a return at the end of the main function. And that's our main function, all right? Okay, let's go ahead and jump in and start talking about what our program is going to do. So it's a pay thing. I think the first thing we're going to review is how to push information into the output buffer. And if you're not familiar with what an output buffer is, I honestly would have expected a second semester programming student to know that, but I have noticed that that is not always covered with a lot of not always covered thoroughly in all classes. So we're going to take a brief moment and talk about that. And actually, I'll use this as a shameless plug to come back over here. If actually you go over to our Lecture 1 helpful resources for the Lecture 1 module, you'll notice that I actually have a thing here called the Programming with Standard In and Standard Out video. This is a video I made to literally talk about that concept specifically, since I've noticed that it's one of those, it's like a real fundamental concepts in programming that I've noticed a lot of students just don't get like a real good grasp of, or they don't really have a firm understanding of it. So I made that video specifically to talk about it. I cover, I demonstrate it in a bunch of different languages, and I also give you a whole bunch of tips and tricks on how you can, build things that will actually capture, and like little tips to be able to track what the input and the output for a program actually are. So shameless plug, but it's a good video. I think you should watch it. I'm going to give you sort of the highlight reel here of it, which is basically an output buffer is basically where you push information. It's like a section of your RAM set aside specifically to hold information that's going to push outside of your program. The most common way that this is done in most, especially starting out programming, a CLI program like this is going to be a mechanism called standard out, and standard out is pretty much always tied to the terminal. Okay, so basically, if you want to push information to the terminal, I'm going to show you how to do that in C++. The way you do it, because C++ is an object-oriented language, you actually use an object to do it. So if you came from a different language, like maybe you came from, I'll just keep using Go as the example, then you might remember you did something like this, right? And then you would say something like, I don't know, hello world or something like that, right? Like in this, you were actually calling a function, and then as an argument to that function, you pass the information that you wanted to push out to the standard out. That is not really how C++ is set up. C++ is a very object-oriented language, which means that objects are kind of meant to be like the primary way that you do things. And so the way that they actually have you set up pushing information to the output buffer is through an object. And so if you include this library, like I showed right here, this IOStream library, one of the reasons why you almost always are going to want that library in your program is because that is where they define the cout object. All right, and so cout, not count, is an object that you get inside of that library, and it is basically a representation of standard out. Standard out. So this object basically represents standard out, or that that output buffer. And so with that object, that means that you have the ability to interact with the output buffer like you would with an object. Now this also gives me an opportunity to talk about something else. Again, another sort of review thing is that because it's an object, it's like kind of like you can think of it as like a variable, right? An object's a variable is a kind of object, right? It just represents an object. And so in that way, when you have variables and you want to do things to them, what do? Well, you have operators that operate on those objects or operate on the variables, right? And so if that's not a super familiar concept for you, you might remember that something like 2, maybe like plus 8. Okay, so this is like a nice math equation. So in this situation, this would be an operand, and this would be an operand, and this would be an operator, right? The operator operates on the operands. Okay, so like that's a real simple way of thinking about it in like a math context, right? Those what those words mean. And so when you're thinking about an object or a variable in this way, it's an operand, right? It's something that can be operated on. And cout has a very specific operator that it uses to push information to the output buffer, or to move information into standard out, in which case moving it into, since this thing is just a representation of a standard out, the operator is these 2 arrows. Whoa, what was that? That was unexpected. 2 arrows pointing to the left. I guess for you guys it would be that way. And this operator, these 2 arrows pointing to the left, is an operator. It is what is known as the insertion operator. So the insertion operator can be used in conjunction with the cout object, and basically anything that you put on the right hand side of that operator, in this case I'm going to have a little message to say, welcome to the pay calculator tool. All right, and I'll even throw a little new line at the end of that. Okay, so this is a string literal, so this is another operand. It's basically a literal string that I'm saying, like, this is something I'm going to, like a piece of memory, if you want to call it that, right? And this is another kind of piece of memory. Again, it's just an operand. And this is the operator that is operating on the 2 things. And so when you use the insertion operator, it will take whatever is on the right-hand side of it, and it will push that data into this. And since this is basically just standard out, it's a representation of standard out, it'll end up on the terminal. So I'm going to hit save right now, and then let's just go ahead and run it really quick just to showcase what that looks like. So again, now I get to show you how you can compile and run your program in C++. So again, we're using the GCC compiler suite. It actually is a suite that can do a bunch of different languages, but we're going to be using C++. So if you want to use the C++ version of it, you would do G++ as the name of the specific GCC tool for C++ compilation. It's the G++ compiler. And then you can just tell it the name of your source file. And so in this case, it's going to be pay.cpp, right? So I'm saying, here's my compiler, here's the source file. And if I hit enter right now, let it run, you'll notice up here, look what just showed up, a.exe popped out, okay? And you might be going like, what's a.exe? Okay, well, that's the executable that was generated as a result of doing the compilation. So I told the G++ compiler, compile this code. It compiled it. There were no errors. There were no problems compiling it. So it was able to link it up and generate an actual executable for me. And now I have the executable. If I want to run that executable, I just have to run a.exe, and I run it, and welcome to the pay calculator gets displayed to the terminal. Okay, so that's what my program does right now. A.exe is the default name for a program if you don't specify a name. If I wanted to specify a name, I would just do something different when I actually compiled the program. I could actually just pass it a compiler flag, which is -o, and let's say I wanted to call it, like, I don't know, pay. If I did that and I hit enter, now look what I end up with is I end up with pay.exe up here. All right, you're never gonna, this is literally the one time you're ever gonna see me do that. I do not care what you name your executables. You're never gonna submit an executable to me. I only want your source code. So you can name your executables whatever you want. Throughout the rest of the semester, you're pretty much always gonna see me just never specify that, but you can if you want. And now Let's go ahead and move on to, let's say I wanted to do this. Well, actually, before I move on beyond that, I also want to demonstrate what this looks like if you run it outside of Windows. So right now I'm running on a Windows-based machine. I'm using MinGW to do the G++ compilation, and this is the default name it gives for MinGW in the Windows environment. If you're running it on a Mac or on a Linux distribution, you actually will have a different default name that'll pop out. I'll demonstrate that right now by running it in Ubuntu CLI. So now I'm running it in Ubuntu, and let's do the same thing, G++, pay.cpp. If you do it this way, now notice what I get. I get a.out. Okay, so that is a slight difference there between the operating system. So if you don't specify a name in the MinGW setup, you'll end up with a.exe. If you're running it on Mac or Linux and you don't specify a name of the executable, you get a.out. Okay, they both do exactly the same thing. So here, if I just run this in there, I get welcome to the pay calculator. There's basically no difference. Okay, I'll switch back over to PowerShell. I'm going to stay over here in Windows for a little while. Another thing to probably worthwhile know is, as I mentioned earlier on, is that you're going to need to be compiling all the programs in this class, not just with the G++ compiler, but you also need to specify the specific version of C++ that you're going to be compiling everything against. So by default, if you don't specify the specific version of C++, the G++ compiler will just use whatever the latest version was that the compiler is aware of. So depending on when you downloaded your G++ compiler, I mean, it'll just use whatever the latest and greatest was. So I don't know whatever the latest version of C++ is now. Maybe it's like 2023 or 5 or something. I don't know. We're using G++ or C++ 11. So just make sure that whenever you compile your program, you have to always make sure to specify exactly the version that you want. And so if you want to do that, you can just do this. Again, I'm going to get rid of that whole pay, but the other way you can do it is just by using a different flag, std equals C++ 11, right? And so I'm basically telling it the standard that I want to use is C++ 11. And by putting that standard as a flag that I pass to the compiler at the time that I'm compiling my program, I'm telling it, make sure to compile this program against this standard. And this is an important thing for you to do because, like I said, that is the standard I am using for all of the grading that I do in the class. It's what AutoGrader will use as well. And so if you forget to do this and you take advantage of some feature of C++ that was beyond C++ 11, it might not compile when you try to run it through C++ 11 compiler, and then it's going to break in AutoGrader, and you might just sit there and scratch your head for a long time. So I don't know how likely it is that will happen, but it could happen. So just something to keep aware that you should always add this flag for everything that you do when you're compiling the work in this class. All right, so now that I've done that, I'm going to run it again. It's just going to override the last executable I have, which means I have a.exe still sitting there, and it still works exactly the same way. Yippee skippy. Okay. Just a little bit more review of what we did here. So we understand what the output buffer is. We understand what an insertion operator is. This is a string literal. I used a double quote to specify that shouldn't be news to anybody. Something to note, you're always going to want to end your programs with a new line character. So this is something that AutoGrader will get persnickety about if you don't do. So this is the new line character. It should also be something you know about. So \n is a very common way. It's a very common escape sequence that references or the the new line character when you're outputting information to wherever you're outputting it to. In this case, the terminal. And I'm just going to tell you right now, like every program needs to end with a new line character. And you might be saying to yourself, like, that seems arbitrary and dumb. Well, I'll just give you a real quick rundown of why we do that. And that's because you don't know where your program is going to be run. You don't know what shell is going to actually be used to run your program. And so if you're making a CLI tool, this is actually just the best practice to do. So if you don't put that in there, like for instance, if I did this, right, and then I hit save and I run it in PowerShell, here, I'll do it again. And we'll run it. It says, welcome to the pay calculator. Seems like that works just fine. Everything looks hunky-dory, right? Doesn't even seem like it made a difference that I had that new line character there, right? Now let's hop over to Ubuntu and see what happens. Now we're running in a completely different shell, right? But I'm going to do exactly the same program, right? So here's this one. I'm going to put the actual flag in there to make sure it runs against C++ 11. right? And then we're going to compile it. And now I have an a.out that should have happened here. So we'll do a.out. And now what happens is, oh, looky there. Look what it looks like now. Well, it did print it out to the terminal, but because there wasn't a new line, the shell decided, oh, I'm just going to start printing the next, opener for the next line on the shell right after it, because there was nothing here telling it to go ahead and start on a new line in the terminal, right? So my point here is that not all shells work exactly the same, and you as a programmer have no way of knowing where it's going to actually get run. So the best practice is to make sure it's always going to look good in every single one. You just put a new line at the end of that, and just by doing that one little thing, I'll run it again here. In fact, I'll just compile it, run it again, and now it looks great. If I go back over to PowerShell and I compile it and I run it again, it still looks great. So you can see right here that it kind of just demonstrates for you that what PowerShell does for you is PowerShell automatically adds the new line if you didn't add it yourself. So it operates a little different than the bash, right? So that's my point. So just know this right now, you're always gonna have to put a new line character at the end of every program, and there's a good chance that your autograder will complain at you if you don't. So just watch out for that. Okay, that's how I added the first line of output to the program. I'm actually going to add 2 new line characters, and we'll just do it that way for now. The next thing I'm going to do is I'm going to prompt the user to go ahead and enter the number of hours they worked for the week. So we'll do another cout, enter number of hours worked. Okay. In this case, actually, just to demonstrate there is another way, you can actually push the insertion operators together. So here is one string literal, and if I want to put something that next to that string literal and also push that to the standard out, I can just use another insertion operator, and in this case I'm going to use a little term called endline or ENDL. It's a special keyword, as again it's defined inside of the here, and that will basically do the same thing that this will do, but this is slightly less efficient, very infinitesimally less efficient, in that this will actually flush the output buffer as on top of just pushing a new line character. So technically speaking, this is a little bit more efficient than that, but honestly I don't care. I just want to showcase that you can do both, right? And then you're going to have that get pushed out to the output buffer. I'm going to go ahead and hit save. We'll run it again. I'll clear this, run it again. And now you see it actually got that out there. And notice how there's 2 new lines after that. So there was the first new line that would have just taken me here, and then another new line, which is what pushed me down here, and then it pushed out this. Oh, a little thing I kind of glazed over here. I didn't really mention it, but notice how the end of this line was with a semicolon, right? So this is something that's very, C++ is like one of its little quirks that everyone ends up messing up at least once or twice when they first start programming in the language. So you must end every statement in C++ with a semicolon. And the semicolon is kind of how the compiler knows that like the end of one statement has happened and that another statement can begin. Actually, a lot of programming languages do this. It's just that C++ is very like specific about it. In fact, if you come from Go actually requires inline characters, or not inline, semicolons to mark the end of every statement. It's just that the compiler lops them on there for you if you don't put them in, which I think is kind of funny. It also is kind of neat because technically speaking, you could also put things together. Since this is how it knows the end of one statement and the beginning of another, there's really nothing stopping me from coming up here and doing this. And this is perfectly valid C++. There's nothing wrong with it. In fact, I can compile this right now, and we'll just clear that and run it again, and look, compiles just fine, and then run it, and look, it looks exactly the same on the terminal, right? So my point here is that you got to make sure you always end everything with a semicolon. If you don't, right, you might get lucky enough to have VS Code help you out, but look how VS Code makes you think that like the problem is over here on this line, even though the problem really is that you forgot to put a semicolon at the end of the previous statement, right? So this is another little moment for me to reemphasize something. VS Code and other text editors are nice. They have these nice syntax highlighting things that'll kind of help you identify where a problem might be happening. But at the end of the day, this is just a suggestion. This is just like an intelligent guess. It is not the authoritative source on whether or not your program is working correctly. It is just a guess. The only thing that is the authority on whether or not your program works correctly is the compiler. So you should always compile your code. So even right now, I'm going to go ahead and compile my code. And indeed, there is a problem. And actually, if you look right here, it's actually much better at it than VS Code ever was, because VS Code says telling you this is the problem. But the reality is that the error is telling you, nope, on line 19, which is the actual line having the problem, expected a semicolon before C out. Look, it's expecting, it's telling you right here. And look, it even has, it's showing you the line. It's saying, like right here, look, there's a little, it's like a little arrow telling you this is where the semicolon should probably be, right? And so, boop, it's telling me there's a problem. I fixed the problem, right? So this is just how the G++ compiler works. I strongly encourage you to get in the habit of always compiling your code. Do not just rely on your text editor to tell you something. It's not always correct. Let's just put it that way. Okay, now that I have spit some things out to the terminal, I've prompted the user to enter some information. Now I need to actually collect the information. So what am I going to need to do? It's time for me to declare a variable. The kind of variable that I'm going to declare to hold this is going to be, I'm going to just go with floating point information. That way, if they want to enter like a fractional time, so maybe they work like 3.5 hours or something, they could do 3.5. So let's go ahead and talk about the different data types that you're going to use in this class and that C++ also supports. So let's just come down here. Maybe I'll just go right here for now. And we'll just talk about the primitive data types in C++. And these are kind of, I'm a little tongue-in-cheek here, it's not 100% just C++, but they are the primitive data types. So the very first one we're going to talk about here is the integer data type, and it holds, as you might have guessed, integer data. Second one is float, which holds a floating point data. Third one we're going to do is bool, which just holds Boolean data. All right, and this is true, in case you don't remember, that's true and false. That means it can really only hold one of two values, true or false. And then the last primitive data type is, character. Let's maybe do individual character data, or otherwise known as basically just a byte. It's a byte of information. And so these are the primitive data types of C++. Now, I say that anybody who's going to Google this or look up anything, they're like, wait a minute, no, you're missing a bunch. There's double and there's unsigned and there's all these qualifiers and other crap. Okay, I don't care about all of the esoteric data types in C++. With these four primitive data types, you can do everything you're going to do in this class. All right, you're not going to need to do anything beyond that. Again, not a C++ class. This is a computer science class. So I just want to focus on these because they are sort of like the foundational building block data types for pretty much everything else you're going to do in computer science, frankly. And so I do sort of expect you already to know what an integer is, floating point data, Boolean, and a character. This one might be a little bit weird for you because you might be looking at this and also be going like, well, wait a minute, where's string? Why isn't string on your list? Well, that's because string is not a primitive data type in C++. Many other languages now have sort of just made that a baseline data type that you don't have to do anything special to use. But in C++ you do. It is not. It is a custom data type in C++. And that might also reemphasize what I mean when I say a primitive data type, in case you can't remember what that means, or if you're looking at this and being like, I don't know what that means. A primitive data type is a data type that is built into the compiler, meaning that the compiler doesn't need to know anything extra or special to know how much space in RAM to set aside in order to allocate space for a variable of that type. Right? So if I declare an int, if I say int x, it knows how much space in RAM to set aside to represent x. If I say float or bool or char, it knows how much space to set aside in RAM to account for that variable. Right? So that's what a primitive data type is. It means it's baked into the compiler. You don't have to do anything special to make it so the compiler knows what you're talking about. Okay. There are other data types, string is one of them, where you have to actually tell it. You have to have a definition for it to know. All right. So we'll talk more about that in a little while, but for today, these are the ones we're going to focus on. We're just doing a little review. These are the primitive data types we're going to use in C++. Okay. So with that in mind, that means I'm gonna, now that I've prompted them to enter the number of hours worked, that means we're gonna now need to actually have a place to put the number of hours they're gonna do. And I just said I'm gonna use a floating point variable for that. So I'm gonna, right here above that, I'm gonna say float, and I'm gonna say, I don't know, hours worked. Okay, and I'll put a semicolon at the end again to denote that's the end of the statement. All right, so this is how you declare a variable in C++. You start with the name of the data type, and then you put the name of the variable that's going to represent that data. Okay, so this is how you do it. The next thing after that, now that I have declared a variable to hold the information, I now need to actually collect the information from the user. So I set aside some space in RAM, said, hey, give me some information. Now it's time to actually collect it. Cout is the object that represents standard out. So you better believe it. There's a whole different object in C++ that represents standard in, and that is cin. Okay. Cin, just like with cout, is a object that you have operators that works upon it. And so in this case, for cout, you're almost always going to be using the insertion operator. So for the cin, you're using the extraction operator, and it's basically just the arrows pointing the opposite direction. Right. So the direction, the arrows are kind of trying to help you out, telling you which way data is flowing. So the arrows are pointing towards this. So it's saying take this and put it here. Right. This is the output buffer, right? So for cin, it's sort of the opposite, saying like, okay, take information from, the standard in, which is like the terminal, right? And I want you to take it from there and put it where? Well, I want you to put it in my variable that I just declared, hours worked. And there you go. So that's gonna, so at this point in the program, since there's nothing in standard in, nothing in that input buffer, it's going to pause the program and wait for the user to type something. And when they hit enter, it's going to take whatever they typed and it's going to try to map that into this variable. All right, so that's kind of what this extraction operator does. It's actually doing a lot of work under the hood, but we'll get into that later. For right now, just trust takes the information from the terminal, puts it into my variable. I'm going to hit save, right? And let's just run it again really quick to make sure that works. Compiles, no problem there. Run it, enter, welcome to the pay, enter the number of hours worked, and see how it's just sitting here waiting for me to type something. So I'm going to go ahead and type 42, the best number, and now our program's done. Okay, so that's how we got going on so far, right? So now we've covered commenting, input buffer, output buffer, string literals, new line characters. We're just whizzing right through all the curriculum, right? Okay, so now I'm going to do basically the same exact thing for collecting the pay rate that the person has. So you have to know how many hours they worked. I need to know how much money they make per hour to be able to calculate their pay. So pay rate, again, same thing. I'm going to create a float here. I'll say pay rate. We'll say cout enter pay rate. And again, I'll just do a new line here, and then we'll do cin pay rate. Okay. Now I might want to throw another new line before I get this one, so otherwise this is all going to be cramped up. So I'm going to go ahead and just throw that new line right there. Pretty nice, huh? That's what I say. We'll just slickly put that in there. Let's just see what that looks like now. Welcome to the tool, 42, and then pay rate, I don't know, 1.5. Okay. So I make $1.50 an hour. That's pretty low wage, right? So here's what I got so far. That looks pretty good. Everything's kind of lined up for you. Something else I'm going to mention, since I forgot to when I was introducing the idea of declaring a variable. So this actually works just fine. And if I'm being perfectly honest, it's a perfectly fine way to do this. Because of how I've set this up. So I basically declared this variable, and the very next thing that happened more or less was just collecting input to put into the variable, right? So there's basically no chance of you running this program and this variable not having data put into it. It's literally the first thing I'm doing. However, in C++, if you declare a variable and I wasn't to do this, if I didn't just automatically use a cin or do something to kind of just push some data directly into that variable, C++ will not automatically assign a value to your variable, right? This is a unique feature of C++. If you were to declare a variable in C++11 and you don't assign it a value, then you might be asking yourself like, well, what's the value of the variable? And the answer to that is a wonderful thing called undefined behavior. So it is undefined by the C++ specification what will happen if you create a variable and you never assign it a value, and then you try to use that variable later on. There's no way for you to know what data will actually be stored in there, right? It will depend upon the compiler, the operating system. It could be literally the time of the day could affect it for all I know. It is undefined. It is up to the people who implement the C++ compiler, and not all C++ compilers are built exactly the same way, especially since undefined behavior is literally a part of the specification. So to prevent that, you don't want undefined behavior. It's bad news. So to prevent that, best practice in C++ is to always initialize your variables. Always, always, always. There's a couple different ways you could do that. My preference is to use the constructor initialization format, which is to basically just use an open and close parenthesis right after the variable, and then just put whatever the initial value is inside of it. This right here would initialize, this both declares the variable and immediately initializes it to 0. Okay. The more common way that you might be accustomed to initializing a variable is to use the assignment operator like this, and that will also do exactly the same thing. So I'll leave those both in there just so you have a reference for both, but these effectively do the exact same thing. Okay. All right. Good moment for me to move on. So now we have the hours worked, we have the pay rate. So now if I want to figure out what their overall pay for the week is, let's say, I have to multiply the hours worked by the pay rate. So what am I going to do? I'm going to create a new variable, and I'm going to say, I don't know, weekly pay, right? And I'm going to use the assignment operator, and I'm going to say is equal to the hours worked times the pay rate. Okay. So this is a good opportunity to talk about. I already mentioned it once, the assignment operator, but here it is again. It's probably a better place to showcase its sort of how it works. So as a review, the assignment operator is a very special operator. Okay, we keep talking about those words, operator. This operates on something. In this case, what the assignment operator does in almost every programming language, it does exactly the same thing. It takes whatever is on the right-hand side of it, and it evaluates that expression, and it becomes a value, and then it takes that value, makes a copy of it, and assigns it to whatever is on the left-hand side of the operator. Okay, again, I'll say it one more time. This is an important thing for you to know. The assignment operator, which is a single equal sign, takes whatever is on the right-hand side of it, evaluates it, becomes a value, and then it copies that value and assigns it to whatever is on the left-hand side of the operator. Okay, that is all that it does. It doesn't do anything else. It doesn't designate equality. This is an assignment operator. This is going to come up. There's a lot of students who seem to struggle with this, so I'm trying to make sure I make it clear. This operator does a very specific thing. So in this case, what is it going to do? It's going to take the variable hours worked, right, which we just grabbed from the user. So there's a value stored in there from what the user typed in. Then it took the value of pay rate, same deal, got it from the user. It performed an evaluation of an expression. So this is an expression on this side, right? It's using a different operator, the star, which is for multiplication. It is going to take this value, multiply it by this value, which is going to have a result. The product of those two numbers is now what the right-hand side of the assignment operator has. That value is then going to be copied and assigned over here. Okay. So at the end of all of that, weekly pay should have the hours worked. It should have the weekly pay, right? That's what it should represent. Let's go ahead and just spit that out to the terminal. Weekly pay, we'll do it this way, weekly pay, and I'll put a colon there, and then I'll do weekly pay. And you can see that this is also another way that you can string things together. Notice how, again, I'm using the insertion operator in a few different ways to push this information out to the terminal. Again, I don't want this to be right after the last thing, so I'll put a new line right at the beginning. And let's take a look and see what that looks like. Welcome to the pay calculator. We'll do 42, and then we'll do, I don't know, 5.3 or something like that. And 222.6. Okay, so right away, it is doing something. I assume that 42 times 5.3 is in fact 2226. That sounds about right. What What I didn't do is I forgot to actually put a dollar sign in front of this, because again, this is supposed to be money. So for me to format this correctly, it would probably make more sense for me to put the dollar sign right there so that it actually shows up that way. But the other thing that I'm noticing is the problem is that, well, this isn't actually how we represent money in the United States. This isn't how currency is denoted. We use 2 decimal values to represent our money. We don't just use 1, right? And so right away, that's telling me that I need some way to format the output of the information that I'm collecting and displaying. So I'm going to go ahead and save this. So let's go ahead and talk about how I'm going to do that in C++. Now this does sort of have me delve a little bit into the intricacies of C++ specifically, but sometimes there's just no way to avoid it. And actually it will help me talk about some other high level concepts. So the first concept that we're going to talk about, if you were to Google this, all right, if you were to ask Google, how do I solve this problem? How do I get it to display the right thing? I can almost guarantee you that it's going to eventually tell you to add a whole new library to your program, right? And it's going to want you to add a library called IOmanip, right? This is a very common library that Google and the internet really loves to have first starting out students use to format their their floating point data. And that's fine. It's a perfectly fine library. And that is exactly what IOmanip is used for. So IOmanip is a library that specifically provides functionality for formatting floating point data on a terminal. That is, or not even just on a terminal, just really formatting floating point data to be represented wherever you want to push it. And so that's the whole point of this. And so in this case, it's a perfectly fine use case for it. We have some floating point data. This is why I held this as a float, right? And so now I'm actually going to try to push that data somewhere I want it formatted a specific way. And so if you want to use that that library to do that, here's what we do. You can actually go into the cout, and then instead of just immediately starting to print like this, you can actually embed a function call. So you can do set precision, okay? And then you can set the precision to 2. By setting the precision to 2, what I'm saying is that like I want 2 decimal values to be displayed every time that you actually have a value to display at all. That's a floating point value. So as long as it has a fractional value, I want you to always display 2 of them, not just 1. Okay. The other thing that I need to do here is I need to make sure that it doesn't apply the precision to the entire number. I only want to apply the precision to the decimal portion of the value, right? And if I want to do that, there's another qualifier you have to put on here, and that is called fixed. If I remember correctly, I don't think this one is actually a part of IOmanip. This is just another one you have to put in. All right, and if I specify these 2 things in my cout statement, it will actually change how that floating point value gets displayed onto the terminal. So we're going to hit save, and I'm going to run it, and we're going to see what it looks like. And actually, here's what we'll do just to be clear of what it looks like before and after. I'm actually going to copy this, paste it, right? And this first one will not have it, right? And then the second one will, okay? Just to showcase what it looks like in both situations. So here we go, G++, run it. We'll do, what are the numbers I used? 4, 2, and 5.3. I think that's what I did. And there it is. And look, just like last time, the first way, when I didn't use precision and fixed, I get 222.6. But when I add the precision and then the fixed, look, it forces it to actually put that trailing 0 at the end of the decimal value. And now we have $222.60. So that is how this is set up, and that is how it's supposed to work, right? So good times. Everyone feels good. But now I'm going to be honest, I'm not in love with this for our particular use case. I'm not in love with this. And the reason I'm not in love with this is because these functions, the fact that you have to put them inside of the same line as like the cout, kind of makes it seem like I'm just applying this to this line of output. But the reality is that this is actually setting it globally. It's actually setting it globally. So for instance, if I were to now come down here and do it again, see, like actually I'll just take this first line, which again doesn't have that set precision on it, and I put it down here again, right? Let's see what it looks like at the end. All right, so we'll do compiles, runs, 42, 5.3, and notice how the very first time 222.6. Okay, so that was, we'll move this over. Yeah, that was this guy. right there. Then I actually did the precision. So now we ended up with the 0.60. And then this one, I don't have precision, but look, I'm still getting the 0.60. Okay. So that's kind of not obvious. To me, at least, it's never been super obvious that that's what's going on, that you're actually setting a global, you're changing the actual object itself. You're actually making a global change to this object, to the cout object, right? And it's not kind of clear that that's what you're doing. And so I've never been a huge fan of this particular library in this circumstance for doing this kind of work. And honestly, you don't have to use it. You don't even need to use the IO_manip library to do this. In fact, this gives me an opportunity to talk about, again, more object-oriented programming, which is what C++ is kind of all about. So if you do not want to have to do it in this way, right, you can get rid of this library. So let's just do this. I'm going to go ahead and comment that out. Right, and just also to show that that one of those functions was coming from the library. So when I remove it, notice how VS Code is immediately like, hey, I don't know what this set precision thing is anymore. That's what it was getting from the IO_manip. And you can, again, don't always trust VS Code, compile it yourself. And now look, you're getting a whole like, I don't know what this is defined in header IO_manip. Yeah, it's letting you know this. See how much better this is? Look how much better of an error message that is than what VS Code's giving you. All right, so there it is. It's telling you that you can't do it that way. Okay. So let's say you don't want to do it that way. Okay, well, there's another way you can do this. Remember what I said, which is that cout is actually just an object. Right? What is an object? An object is basically a value that is derived from a custom data type. Right? So there's a custom data type that represents cout, and that custom data type has functionality attached to it. So this is, again, something that I would have expected somebody in your first programming and algorithms class to discuss, the idea of a custom data type, and that there are sort of like member variables or attributes associated with that data. And indeed, there's usually functionality also associated with that data. And cout is no exception. If you go cout and then you just do dot, you get all of these functions and all of these values. Right? And so there's a lot of things that you can do with this specific object. And one of those things is that you can actually just set precision directly off of it. And you can say what the precision should be. Now, to me, that is a lot more obvious of what's happening. Rather than me baking it into actually using the insertion operator, where it looks like I'm actually pushing data into the object, instead this just looks like I'm changing something about the cout object itself. I'm actually changing this variable in some way. This is basically a setter. And if you don't remember what that is, if you never had it exposed to you, don't worry, we will eventually talk about it. For those who know, that's kind of what we're talking about. This is basically just changing something, some piece of information on this object using the dot operator. I'm setting the precision to 2. Now let's say I want to change the fixed value for that object, cout.setf iOS fixed. And now I have said the cout object going forward, the precision will always be 2, and it's always going to be formatted in fixed notation. Okay? So this is not part of like me actually printing information out to the terminal. This is just me saying, hey, I'm changing something about this object now. And by doing that, notice how I didn't have to do anything weird like this. I have at one point in the program, this is before I set that precision. So if I run this right now, this will be this way, right? Then I changed the object, then I printed it again, and notice how this looks identical to this. There's no difference. The only difference is that this one happened before the change, and this one happens after the change. So let's go ahead and save it and run it. And we'll do 42, 5.3, I think is what I was using. And indeed, it looks the way it's supposed to look. It changed it. And now if I keep doing couts afterwards, it will continue to have the 222.60, or basically will continue to have this precision set to 2 decimal points, but it at least makes sense to me now. Also, I didn't have to include a whole separate library. There was no reason for me to do this. I didn't need to add an extra chunk of code into my code to make it do what I wanted it to do. I could just do it using the object directly the way it's already meant to be used. Okay, so I would argue this is probably the better way to do this. All right. Again, this is a little bit C++ specific, but also let me have a chance to talk to you a little bit about um, how to use objects and object-oriented programming and kind of the design principles behind that. And then showcasing that C++ is kind of built with that in mind. Okay, the last thing I really wanted to focus in on for this first lecture was the last concept that I wanted to kind of review was the idea of a conditional. So in that case, the if statements. In C++, they're pretty much exactly what you would expect them to be. They're pretty straightforward. Conditionals are pretty much the same in almost all programming languages, so there's nothing special or weird happening here. But in C++, the way you would do it is, of course, with the old if statement here. You're going to have an open and closed parenthesis. That's not always true in all programming languages. Some languages don't require the open and closed parenthesis, but C++ does. And then inside of the parentheses, you would put your Boolean expression. For the sake of this program, let's just say if, let's say, the weekly pay is greater than 50, right, $50, then I will, in the body of the if statement, say, I'll make a cout statement here, and we'll say something like, oh, new line, pay more than 50 bucks. Hey, pretty good, right? Again, I want that \n because I want my program to always end with a new line. All right, and then if I wanted to, here, we'll just go ahead and save it right now, see what happens there. So if I were to run this program again, and I were to do 42 again, just like we've been doing all along, weekly pay more than 50 bucks, because 222.60 is more than 50, so that stands about right. And here, you know what I'll do? I'm actually going to comment this guy out because I don't need that there twice. And then we're going to also, now I'm going to add an else. So the if statement, if this Boolean expression evaluates to true, then everything inside of the two curly braces in the body of the if statement will run. If this evaluates to false, then it will be skipped. In fact, before I do this, let's just prove that that works. This should all be kind of review, but I do want to make sure everyone's aware. So we'll do, in this case, I just need to make it less than 50 bucks. So we'll say I worked for 1 hour at $3 an hour, and then I made $3. That's it, right? And notice how it didn't print out weekly pay more than 50 because it wasn't more than 50, because 3 is less than 50, right? All right, so let's say I wanted to have a situation where it evaluated that, and if it wasn't more than 50, I could put an else clause on it. Else, again, I'm going to have this. Now, there's no Boolean expression associated with an else. In this case, it's just whether, if this evaluates to true, then this happens. And in any other circumstance, this happens. So what are we going to have here? Cout weekly pay less than or equal to 50. Okay, and that should be true. So it's either more than $50 or less than or equal to, right? So let's do that. Again, we'll use the exact same numbers I just did a second ago. So what was that? $1 and $3. Oh, it didn't print it out. Wonder why. Greater than $50. If it's not greater than 50, oh, where's my thing? Okay, not greater than $50, then it should have printed out weekly pay less than or equal to $50. Okay, well, I'm surprised that I didn't get that printed out. Let's investigate a little bit more here. Maybe I pushed in the wrong numbers, or maybe I didn't save. That's probably the most likely thing, is I just didn't save. So we'll do $1, 3. Huh, that's sort of weird. Am I just a crazy person? Else, yeah, if the weekly pay is greater than 50, then do this. If it's not greater than 50, then I should get weekly pay less than or equal to, that's very curious why I'm not getting the number. Try one more time. Well, hey, let's just try it with 50 again, something that's greater than 50 to confirm that it works. Oh, I don't think I compiled. I didn't compile. That's my fault for not compiling it. Let's try it again. 1 and 3, and there it is. Okay, you have to compile your program every single time or you end up looking like a silly guy like I just did. Okay, so that works. The last thing I want to showcase here is if you want to do more than one if statement. So you can actually chain your if statements together. You may recall using an else if. So let's do else if. In this case, I'm going to say weekly pay, let's say is greater than, and if actually let's do this. We'll say if greater than $100, then we'll say is greater than 100. And if it's not greater than 100, then this one is where it will check if it's greater than 50. And I'm just going to copy that. And we'll come down here and we'll say 50. Okay, there's all that right there. So here's how it works if you put an else if in. The first if statement is the very first one it will evaluate. It'll say if the weekly pay is greater than 100, if this evaluates to true, then it will run everything inside of this block and it will skip everything else. Okay, if this evaluates to false, then it will actually evaluate the second condition. And if this condition is set to true, then it will run this and it will skip everything after that. And if this evaluates to false, then it will move on. And since there's just one else clause, then that always runs if the other two don't run. Right? And you can add as many else ifs as you want. Also, I'll go ahead and maybe I'll make this a little bit different. I'll say greater than or equal to. So more than or equal to $50. And then this one can actually change to just say weekly pay less than $50, because now if it was equal to $50, it actually would land here. All right, so there we go. There's that one. And now I need to make sure I end up at, let's say, some number between 50 and 100. So let's go ahead and run it one more time. Again, let's make sure to compile, run it, and we'll do, I don't know, $50. Or let's say I worked for 1.5 hours at $50 an hour. That should definitely put me between 50 and 100. And exactly, more, I made $75, weekly pay more than or equal to $50. And notice how that's the only one that actually got printed out and the rest of them were ignored. So that's how you can do conditionals in C++. Again, all of this is stuff that I sort of expect you to already know conceptually, all of these concepts that I just reviewed. I'm hoping that none of that was actually new information for anybody. If it was, hopefully this was a fairly quick review for you. But the main things I was trying to focus on today was just introducing the C++ syntax to you and showing you how you can kind of implement those concepts using that syntax. All right. Well, that's pretty much all I have for today's first lecture. And so we're going to go ahead and wrap up this programming introduction for you. Just remember that you're going to need to focus on getting your homework done for the week. And in fact, maybe I'll just take a brief moment to showcase what that looks like. So let's go ahead and jump back over to the syllabus here. And we'll go back. And all the things that I just show you how to do are meant to help you with the tip calculator assignment for the week. So for this particular assignment, I'm asking you to do something pretty similar to what I just did with the pay calculator. Basically, you're going to be writing a program that calculates how much of a tip to leave based on the quality of service that you got at a restaurant. So you can imagine if you went to a restaurant, this is kind of what it would look like. So it's going to present them with some menu options, right? And then they're going to pick whatever option they want, and then that's how they're going to it's going to calculate the tip, and then it's going to display the tip. So they're going to enter some information, make some decisions, print something out, very similar to what you just saw mine do. Also, just taking note of the format that I use for all the programming work in the class. When I put the directions for you in Canvas, this is kind of the format and setup that I use. So notice how it says, welcome to the tip calculator. How much were you charged in dollars? Now notice how all the example output, you'll see this a lot, where I say the input in bold and underline for clarity. This is my way of saying that this is example output, and in this example output, anything that is bold and underlined, which right now I have highlighted one of the bold and underlined sections, this is meant as an example of input that could come into the program. Okay, so if you were running this program, I expect this to be the first thing that pops out of your program, this to be the second thing that pops out of your program, and let's pretend that the user typed in 22.50, then this should be displayed, and then let's say the user entered a 2, then these are the outputs that should happen with those two kinds of input, right? So that's my way of distinguishing the input from the program from the output. Another thing to note is that your output needs to match exactly what is set up in the example output. Let me repeat that. The example output, this is not a suggestion. This is a requirement. Your program, all of your programming work, when I give you example output like this is what your output needs to look like. Down to the new line characters. It needs to look exactly like this. If it is off by any part of that, AutoGrader is going to let you know. It's going to let you know very quick. This is probably one of the number one things that students learn early on in the class, is that if your output does not match exactly what is specified in the assignment directions, you're not going to get full credit. It's going to tell you there's something wrong and that you need to figure it out. And it will try to help you in that, telling you maybe like the line number, the output line number that the problem is happening on. But in the end, that's on you to figure it out. That's what it is to be a programmer. Not everyone's always going to be hand holding you through every little problem that you have, right? Most of programming is running into problems, things not working exactly the way they think they should, and then you having to figure out how to make it work the way it should, or the way you want it to, or the way your teacher is requiring you to do it, or your customer is requiring you to do it, right? So this is very intentional that I'm doing it that way. I usually try to provide you multiple examples, and notice that the only difference between any of these examples is literally what the input is. So this is just a showcase for you what the output, like what the end result output would be if, let's say, they were charged $34 and they left a 20% tip, then the tip should be $6.80 and the total for the bill should be $40.80, right? Whereas in this one, the the bill was $22.50 and they left a 15% tip. That means it was a $3.38 tip, and that $25.88 was the total. Right. So that's the whole point of this. Again, always review the grading rubric. Very good idea for you to know what is going to be the most important thing for the assignments and how AutoGrader is ultimately going to evaluate it. Okay, well, that should wrap up everything that I was going to talk about for our first lecture. I know it was a little bit of a long one, but I got a lot to get through. Just as a reminder, please make sure to go through and knock out everything in the course overview module. That's all that stuff has to be completed before you'll be able to access anything in the example code or in the lecture 1 module for the week. As a reminder, everything for this first week is going to be due on Friday. So that's the Friday, the August 21st is when all the stuff from the lecture 1 is due. But that August 20th is when all of the stuff for the lecture 2 module will eventually be published, so that you'll actually see everything, and that will include a new lecture that will cover all of the things that you're going to be expected to know for that week's module. So just a reminder of how you have to have everything set up in the class. Well, thank you again for watching the whole thing. I'm looking forward to meeting all of you, especially during our lab time, and I'm looking forward to an excellent semester full of lots of programming and meeting all of you in person. All right, until then, adios.